Hello, I'm Hector Perez. Welcome to the Learn TypeScript from Zero to Expert course. I'm thrilled you're joining me on this super interesting and exciting course that will allow you to write TypeScript code in just a few hours. But before that, I need to explain to you what TypeScript is, along with a few concepts that will help you understand the code, will be writing more easily, and leave no room for any doubts. The first question we need to answer is, what is TypeScript? But before that, let's take a quick look at the history of JavaScript and understand why TypeScript helps improve JavaScript-based projects. JavaScript, also known as ECMAScript, remember this well, started as a language based on very simple scripts for browsers. It was created by Brendan Eich. The truth is that when it was invented, no one knew the immense importance it would have today. The idea was to embed small snippets of code within a web page. Even a page with more than a dozen lines of code was extremely rare. Because of this, the first browsers ran this code very slowly. Over the years, JavaScript became more and more popular, and developers started using it to create interactive experiences. This is how the people in charge of web browsers began optimizing execution engines, which allowed for an even wider use of JavaScript. Today, a web browser runs hundreds of thousands of lines of code. Its importance has grown to the point where JavaScript has become so popular that it is used outside the context of web browsers, for example, implementing JavaScript servers using Node.js. Its ability to run anywhere makes it an attractive development platform for multi-platform development. There are even developers who use only JavaScript for their entire application stack. However, due to the initial purpose of JavaScript being used for very simple things, there are several peculiarities, to put it mildly, that could cause an application to encounter errors without us realizing it. For example, if you quickly view this image and know about JavaScript, you might think the code is correct, as we don't have any kind of warning or error. However, we can see that the output displays a message, none. But why? Well, carefully observe the image, and I leave it as homework for you. These types of simple errors are easily handled or resolved in small projects. But when we're responsible for projects with hundreds of thousands of lines of code, locating an error like this can take us even days of debugging and analysis. Fortunately for us, there's TypeScript. Now, let's see what TypeScript is. Basically, TypeScript is a language that's a superset of JavaScript, which means it extends JavaScript by adding types. We can find 4 relationships between TypeScript and JavaScript. Let's look at them. First, let's discuss syntax. The important thing to know is that all JavaScript syntax is legal syntax in TypeScript. Syntax refers to how the code is written to be correct. For example, on the screen, we see a piece of code missing a parenthesis. TypeScript doesn't consider any JavaScript code as an error due to its syntax. This means you can take any working JavaScript code and place it in a TypeScript file without worrying about exactly how it is written. However, as we've said before, TypeScript is a typed superset of JavaScript, meaning it adds rules about the different types of values that can be used. In this example displayed on the screen, we can see that it's a piece of syntactically correct code in JavaScript. However, upon executing the program, we would see the word infinity as a result. On the other hand, TypeScript would throw the error we see on the screen, indicating that the division of a number by an array is a meaningless operation, resulting in an error warning. It's possible that you can actually intend to divide a number by an array, perhaps just to see what would happen. But most of the time, however, this is a programming error. The TypeScript type checker is designed to let correct programs pass, while still catching as many common errors as possible. If you move some code from a JavaScript file to a TypeScript file, you might see type errors depending on how the code is written. These can be legitimate issues with a code or TypeScript being too conservative. Another thing that TypeScript does is that it maintains the runtime behavior of JavaScript. For example, dividing a number by 0 will produce infinity rather than throwing an exception. This is important to know. TypeScript will never change the runtime behavior of JavaScript code. This means that if you move code from JavaScript to TypeScript, you can be sure that it will run the same way even if TypeScript knows or thinks there are typing errors. This is so you can make the transition between the languages without error correction, preventing you from continuing with your project. Lastly, once the TypeScript compiler has finished checking the code, it eliminates or erases the types in the compiled code, meaning the resulting source code does not contain any information about the TypeScript types, ensuring the JavaScript code runs the same way. In addition, TypeScript does not provide any runtime libraries, so there are no additional TypeScript-specific frameworks to learn. A common question I get asked is, should I learn TypeScript or JavaScript? The answer is that it is not possible to learn TypeScript without learning JavaScript. This is because TypeScript shares syntax and runtime behavior with JavaScript, in such a way that anything you learn about JavaScript will help you learn TypeScript at the same time. There are many resources for learning JavaScript available today. In fact, there are up to 20 times more JavaScript questions than TypeScript questions on Stack Overflow. It's extremely important to remember that if we are looking for a resolution to an algorithm, for example in TypeScript, and we can find how to solve it this way, we can always look for the solution in JavaScript, by which we can solve the problem easily. Having said all this, we're going to spend a good time learning TypeScript. In this video or lab type setting, we're going to reinforce the knowledge we've gathered from the previous slides by examining some examples of why TypeScript can assist us in developing our JavaScript-based code. To start this exercise, I'm going to open a new project on this site, playcode.io, which you can find as part of these lessons attached files. What we'll do next is open a file called script.js. This file essentially allows us to execute JavaScript code in a very simple way. For instance, if we do a cancel.log and write a message such as hello, notice how we immediately see the result in the console at the bottom. With this, we'll verify that with JavaScript we can make some mistakes that might not be intentional, but could affect us when developing a project that utilizes JavaScript code. We'll proceed to delete this code we have here. I'm going to create a very simple function. So let's create a function. We'll call this function add and indicate that we want to pass a first and a second number. As part of this function, we're going to return the sum of number 1 and number 2. Here, we see that this JavaScript compiler shows us some issues while writing code. For example, notice that it flags some errors. These errors are more syntax errors. Here, it suggests some corrections to, well, fix this code essentially. I'm going to correct this program or function, and I indicate that I'll be returning the sum of number 1 and number 2. Let's change this to number 1. Basically, we now have a function that processes or adds two numbers and returns the result so that we can sum them. For example, by calling this function with two numbers in a console.log. For example, a number 2 and another number 2. Notice that as part of the result, we have here the number 4. With this, we see that we can easily write code in this editor. Here we're going to make a mistake that could potentially happen to you when you're writing real code in your program. Take a look at what happens if instead of sending a number 2 to my function, I send, for example, a number 2 or rather a number 10, but in quotation marks. This representation in quotation marks means we're sending a string. Notice that this JavaScript code doesn't cause any error, but on the console we have the number 210 displayed. You might think this is incorrect, because the sum of 2 plus the number 10 should actually be 12. However, on the console we have the number 210 displayed. Why is this happening and what should we do to fix it? Well, the problem here is that we are sending a text string. When in JavaScript it detects that we're sending a text string and try to apply this addition operator, what actually happens is that two strings get concatenated. In this case, it converts these two into a string and basically concatenates the string 2 plus the string 10, even if I pass a text here. Notice that it concatenates the text and the number 2, which probably isn't the result you'd expect from a function called add or sum. What you expect is that it will always return the sum of two integers. So this is a problem we have with JavaScript, that we don't have a way to validate at writing time something that indicates us that we are making some mistake and therefore we could have some sort of problem in the future. What can we do to solve this? Or rather, how can TypeScript help us address this issue? Well, what I'm going to do is open a new window in a new browser, for instance Google, and search for the keyword TypeScript. As the first result, we have this URL, typescript-lang-dot-org. Let's visit this website, and as part of this site that we'll explore later, let's go directly to the button that says Try in your browser. This will load a TypeScript editor. What I'm going to do next is to copy this JavaScript code I have here. I go back to the TypeScript playground. I paste in this code. Notice that we immediately have a few errors pointing out that we have some kind of problem with this TypeScript code, because we are in a TypeScript file. But notice something important here. If I click on the button that says Run, notice that this code in my editor executes, and absolutely nothing happens. This is part of what I mentioned earlier, that we could have some problems with our JavaScript or TypeScript code, but this behavior will not be affected and will execute normally. That's one of the promises that the TypeScript team makes, that we can run the JavaScript code exactly as we have it, without any issues requiring us to correct all the problems before we can execute a JavaScript-based program. Okay, so let's now return to this error section. Look at what's happening here. Here we essentially have a few problems indicating that the parameter number 1 has a type of any. We'll look further into what this any type means later. But essentially, what's happening here is that we are not specifying a specific type for these parameters called number 1 and number 2. This TypeScript is interpreted as it could have some kind of problem in the future, or we can have unexpected results. This is precisely what's happening. With TypeScript, assigning a type to a parameter is quite simple. We just have to add 2 points followed by the type of data that we want to specify for this parameter. In this case, it's a data type number. We will discuss this data type later. Don't worry about it right now. To this number 2, I am also going to add 2 points, and I am also going to indicate that I want a data type number. With this, we have resolved this issue that the parameters we pass to this function already have a specified data type, which will force us to pass specifically a numeric data type to the first parameter and a numeric data type to the second when we want to use this function called add. Notice that once we solved this issue, a second error message appeared telling us that an argument of type string can't be assigned to a parameter of number type. This alerts us to a problem in our code. Specifically, we are trying to pass a string to a numeric parameter. With this immediate awareness, we can recognize that there is a problem and change it to a numeric value. Notice that the list of errors disappears when we execute this code, and we end up with the result we expected. Therefore, in this manner, our programs are more reliable. Our programs allow us to know in real time if we have some kind of problem while writing the code. Imagine if we used this function at many points in our programs or applications. We would quickly highlight any problem in our code or function. So we're going to see how to use TypeScript to create these kinds of reliable programs that are TypeScript based. We have already seen a demonstration of TypeScript within a TypeScript site itself. However, I don't think you want to develop all your programs with TypeScript within this browser. Therefore, it is important to have a program editor that is easy to use and helps us as we develop our TypeScript programs. We're going to do this using Visual Studio Code. I have here a machine on which I have recently installed Windows. So I'm going to show you the exact process that needs to be followed to install TypeScript within Visual Studio Code, step by step, so you don't miss out. The first thing we're going to do is open a web browser. We're going to head to Google, for example, to search for Visual Studio Code. Once we've made this search, what we're going to do next is click on the first link that says code.visualstudio.com. Okay, once we're on this site, we're going to click on the button that says Download for Windows. Or if you have a different operating system, you can choose the version for Mac OS or even Linux in its 64-bit version. I'm going to click on Download for Windows. This will start a download, which I will run directly. Let's give it a few seconds for this installer to download. This initiates the Visual Studio Code installation assistant. I click on I accept the agreement. I click on Next. I will leave the installation path set to its default. I click on Next. Again, I click on Next. Here, under Select Additional Tasks, I'm going to select all the options. It is really helpful to me whenever I'm faced with a file in Windows Explorer that I don't know what it does or if it contains any code or source I want to view quickly. The Open with Code option is very helpful to me. So I'm going to select all of these options. This is optional. You can do it if you want, or if you don't want to, you can leave them unselected. I click on Next, I click on Install, and this begins the installation process of Visual Studio Code, which is actually very fast. Let's give it a few seconds. Okay, after a few seconds, we see that the installation has been completed. We can run Visual Studio Code directly once we exit the installer. This will start the Visual Studio Code application. Indeed, this editor has recently gained a lot of popularity. Let's quickly give an overview. We have some options at the top. We have the menu that allows us to carry out different tasks. We will work with some of them later on. On the left, we have different options. For instance, we have Explorer, when we can oversee which folders we have open for a particular project. Alternatively, we can also quickly search within some files. We can manage the version controls if we happen to use this feature. We can even execute programs for step-by-step debugging. There's also a very interesting section called Extensions, where we can install some useful extensions. We will see later on what extensions I recommend installing for working with Visual Studio Code. And finally, we have the settings section where we can make different configurations, such as setting the font size, deciding whether we want to automatically save files or not, and choose the font for text editing, among other features. This configuration section can be configured as you feel best. It's not mandatory to use the same configuration that I'm using. So feel comfortable and set it up as it suits you best. Once we have installed Visual Studio Code, we're going to see how we can work with TypeScript. To carry out this task, we'll return to a web browser. As you may recall, I previously mentioned that if you wanted to reach the main TypeScript page, you had to go to a browser, search engine, and type the keyword TypeScript. This lets us to, or the first result we find is from the official TypeScript page, which is typescriptlang.org. We're going to the main site because I want to show you something. Note that on the main page we have two buttons. The first button was the one we used in a prior video, indicating that we could test this powerful language in the same browser. But we have another button here that allows us to install TypeScript locally. Let's see what this button shows or gives us. Note that it indicates that we have to use or can use Node Package Manager to install TypeScript. However, if we try to use this line as part of Visual Studio Code that we just installed, I'm going to close this configuration section. How can we execute this type of command line? Well, let's go to the terminal. We click on the new terminal. Here in the terminal, we can proceed to write anything we want to execute. In this case, I'm going to paste this line, but notice what happens. I press the Enter key. It tells us here that the term npm is not recognized as a command-led function or script file name. Basically, this is telling us that we don't have Node installed on this computer where we are trying to execute this line we have here. How can we solve this problem? Well, we can open a new browser window and search for Node on our favorite search engine. This sends us to the first result we get is the main page of NodeJS. Let's proceed to click on this link. We have different forms here for downloading Node. We can download version 14.15.4, which is the recommended version at this time for most, or the latest version. I'm going to go for the current version. If you use the LTS version, there's no problem. I'm going to click on the button that says Run. Wait a moment while the download of this installer completes. Okay, this starts the Node.js installer. Let's click on Next. Let's accept the terms and conditions. Click on Next, Next, click on Next, Next, and finally we install Node.js on our machine. Once the installation is finished, we can click on the button that says Finish. We have now installed Node.js on our machine. Let's restart Visual Studio Code to see everything is working correctly. Click on Terminal. New Terminal. Let's copy this line we saw on the TypeScript page again. Let's proceed to paste this line again. This has installed a package as part of Visual Studio Code. With this, we have successfully installed Node.js and the TypeScript compiler. We return to the main TypeScript page and see that essentially it tells us that after installing TypeScript, we can run the compiler through the tsc command. Let's go to Visual Studio Code, run the tsc command, yet notice that we now have another issue. This issue basically tells us we can't execute this command due to the script execution being disabled on this system. To solve this problem, I'm going to paste a line which is the one you see here. Set execution policy space execution policy space remote site net space scope space current user. This will allow us to execute the tsc command. Notice that if I type tsc again, it will not show any type of error. It indicates that we need to correctly complete the script execution to carry out some type of test. We will see how to create our first TypeScript-based program in the next video. Once we have installed Node.js and also installed the TypeScript compiler, the TypeScript compiler we ran earlier with the command tsc, whose real name is TypeScript compiler. We then have these two parts to successfully create our first program based on TypeScript. This is really straightforward. You will see how simple it is. The first thing we're going to do is go to this section that says No Folder Opened, within this first section called Explorer. Here we have an option that says Open Folder. We can click on this button and this would unfold or open the Solution Explorer for us. Let's go ahead and create a new folder. I'm going to create it in the Documents section. You can create it wherever you want, except those classic restricted places like C, program files, etc. So let's create a new folder and I'm going to name it, for example, TypeScript course. Once I create this folder, I'm going to proceed to create another folder which will contain this series of files that I'm currently creating in this video or in this series of videos. I'm going to call it, for example, Hello World. Once I have created this folder and I am inside the Hello World folder, I'm going to click on Select Folder, and this will configure Visual Studio Code to have this folder open within Visual Studio Code. Notice that we have this Hello World folder here and it doesn't show us anything, since this folder is currently empty. Let's proceed to create a new file by clicking on this icon that says New File. Notice it appears here part to give our new file a name. Let's call it, for example, helloworld.ts. This is important for Visual Studio Code to identify that it is a TypeScript-based file. Press Enter and this opens this file in a new tab on the right side. Here we essentially have this editor where we will be able to start writing our TypeScript code, which, as I previously mentioned, is compatible with JavaScript. The first thing we will do is write a very simple program, console.log, and in parentheses and quotes, hello world, the classic hello world of a programmer's life. Now that we have this code, which is a very simple line of code, we're going to learn how to compile this file to generate the resultant JavaScript file from the TypeScript file. It's important to know that a TypeScript file, unfortunately, cannot be read by browsers. So we have to convert this TypeScript file into a fully valid JavaScript file so that it can be used by a web page, for example, that makes a reference to the JavaScript file and can use this code. The TypeScript file is only what will allow us to carry out certain validations or allow us to write code that doesn't have as many errors and that we can generate the JavaScript file from it to attach it, as I said before, to a web page. So, to carry out the compilation, we'll click on this option that says Terminal, New Terminal. This brings up the terminal. This loads the terminal, and once we have done this, we can write tsc, just as we did before, space, and we write the name of the file we want to compile. In this case, our file is called helloworld.ts. We have to write out everything, including the extension. Once we have done this, press the Enter key and watch what happens. Okay, this produces a JavaScript file without us having to interfere at all. This is automatically generated. This TypeScript code we have created, see what it has produced. We open the JavaScript file by clicking on it. This opens a new tab with the JavaScript code. And see what has happened here in this case. It created a blank file, and if this happens to you, or it happens that it compiles but it does not show you the changes in your JavaScript file, you have to take into account that it is because you have not saved the file. In my case, I have not saved this file, unfortunately. So what it will proceed to do is click on File, Save, or you can use the shortcut Ctrl+S. I'm going to use it. Even on the left side, we have this icon that indicates that a file needs to be saved. Notice that it tells us here that we have a file that has not been saved. Here we have this message. And basically, what I'm going to do is save this file. And once I have saved the file, it indicates to me, or rather, this icon that indicated that the file had not been saved disappeared. I will return to the terminal. I will press the Up key to display this command I ran earlier. We press the Enter key once more. And we realize that the compilation has finished because it shows us a new empty line as shown here. With this, we can now return to the helloworld.js file, and this time it did display or generate the resulting JavaScript file with the code from the TypeScript file we had here. So if this happens to you, remember that you first have to save your TypeScript file to successfully generate your JavaScript file. In this simple way, we can carry out the generation of JavaScript code from a TypeScript file. It is very important that you learn the syntax tsc and the name of the file. Later on, we'll see a method where we only need to save this TypeScript file to automatically generate the set of JavaScript files. We'll even see how we can refresh a web page with the result of generating JavaScript code, but we'll visit this later. We have already installed TypeScript on our machines. We have also carried out the first compilation of our first program created with TypeScript. What is the next step? Well, the next step we're going to see in this video is to install some extensions that I consider to be very useful for development with TypeScript within Visual Studio Code. Let's see what these extensions are. We're going to open the extensions section by clicking on this icon that appears here within Visual Studio Code, and we're going to install some extensions. The first of these is one called ESLint. Notice that there is a star here that indicates that it is a suggested extension due to the type of files we have recently opened. So we click on this button that says install, and this extension will basically allow us to carry out some additional checks to ensure that the TypeScript files are completely valid. We are then going to install this extension. The second installation that we're going to carry out is that of Material Icon Dim. This extension will basically allow us to see in a very visual way the files we are working on, as well as the files within the Explorer, within Visual Studio Code. These are essentially the icons that this extension supports. We are going to install this extension and see what's going to happen at the top. First, we have to choose which theme we want to use for the icons. We currently have this option, which is SETI from Visual Studio Code. We are going to select Material Icon Dim. Notice how the Explorer part changes. We now have a new type of icons that will allow us to very easily and visually see the files we are currently working with. Another of the extensions that we're going to install is one called Path Intelligence. And essentially, this extension will allow us to carry out, as the description tells us, the autocomplete of file names. This is something we will use later, but I suggest you install this extension. The last one is called Prettier, which is essentially a code formatter. This extension will enable us to format our source code if, for instance, we need any sort of semicolon or any type of bracket completion, etc. Let's install this extension. Essentially, to use this extension called Prettier, we can go to the part that says File. Here we have the Preferences section. We have an option called Keyboard Shortcuts, and if we look for Format, we have an option that says Format Document. Here we can see which shortcut is currently assigned to carry out this code formatting. If we press the keys Shift plus Alt plus F, this will allow us to properly format our source code. For example, if in this Hello World file we didn't have the semicolon and we press Shift Alt F, this indicates that we have multiple formatters for TypeScript files. We have to select one. We click on Configure. We select which one we want to use. In our case, we use Prettier, which is quite good. Notice how the missing semicolon is easily completed. This way we can perform the code formatting. Even if we press additional tabs for this code and press the key combination again, it formats in a way that is visually readable, so we don't have those jumps that sometimes confuse us when reading the code. So these are extensions that I recommend you install and have in Visual Studio Code for development with TypeScript. Remember, they are entirely optional. You can choose not to install them, and it's perfectly okay. I recommend installing them so you can visually see some features or errors in a simpler way. In this section, we're going to start talking about the different predefined data types that we can find as part of the TypeScript language. We talk about predefined data types as these data types are directly part of TypeScript. We could also create our own custom types according to our needs, but this is a topic that we will see later in the course. Let's see what the predefined data types are. Let's start with the first predefined data type. The first primitive or predefined data type is the number data type. Basically, with this type of data, we can include or declare variables of any number we want, including floating or decimal points, hexadecimal numbers, and even binary numbers. So, any number that you think you want to declare as part of your program in TypeScript, you're going to be able to use or have to use the number data type. Here are some examples. We see that, for example, the number 5 is an example of a number or a number data type. The number 10.7 as well. A negative number like -1000 would also fit within the declaration of this number data type. Let's see a practical example of this type of data. Well, we are here in the browser, and we're going to start using the TypeScript playground. This is because we are going to do different tests and we don't want to be carrying out the compilation in a repetitive way, in such a way that it bores us or that we don't see the result immediately. Later, as I mentioned, we will see how we can automate the process so that we can directly visualize the code generated automatically when saving the file in Visual Studio Code. For the moment, we are going to use the TypeScript playground. We will start by writing some valid code that is part of the JavaScript language. For example, this method that we're going to create would be totally valid in JavaScript. We can declare a function called calculate square area, and this method or functionality would serve us to calculate the area of a square. We're going to indicate that we want to pass as part of this method simply a site, so that it carries out the printing via a console.log side by side. So basically, when invoking this function, the result of the side by side would be printed to us. Here we could directly invoke this method by passing, for example, a number 2. And we're going to click on the button that says run to see the result on the right side. Here it seems that everything is fine, and we have here a red section or a TypeScript marker indicating that there is some problem. We had already seen this in a previous video, but basically revisiting it, here we have a problem because it is indicating that this parameter of this function can be anything we pass to it. For example, if we were to pass here a hello and we execute this code, we see that we have a different result. We have a result of none, or an error that we are basically provoking because we are sending a string when the multiplication of two numbers is expected. We are going to solve this. To solve this, we're going to proceed to declare a new variable. We can do this in JavaScript either with the word const in case we don't want a certain variable to be modified later in the program, or with a let in case we want this variable to be modified later. Let's do some tests with the keyword const and let's declare a variable called square side. We're going to proceed to declare a number as part of the variable assignment, for example a 10. And instead of passing a parameter or value directly to the method, we're going to pass this variable we have declared. At this moment, if we run this application, since we are sending a valid number, the multiplication is done correctly and we have no problems. However, we still have the issue that we can send a string and we get this non-result or the error we saw previously. Okay, this is valid code in JavaScript. As you have seen, we can execute the program. There's no problem if the compilation doesn't come to fruition, because we have some sort of issue, and so on. But since it is valid JavaScript code, therefore TypeScript successfully carries out the compilation. The only issue is that we are throwing an invalid value on the console. In another case, if we had a more complex application, we really wouldn't have a way to know during coding that we have some sort of problem, as we had already seen in a previous video. How can we solve this? Well, we can apply data types to a variable. Hence the name TypeScript. Because TypeScript means that we can insert or we can type the data in a JavaScript-based program to somewhat enforce having a number or having a string. This means that we can force the user to input a correct value when we are declaring a certain variable of a certain type. In this case, for example, if we already know that we're going to receive only a number, then we can specify that we want this variable to be of the data type number. How do we do this? Well, by placing a colon and specifying the data type we want to assign, which in this case is the data type number. You'll see that with this approach, an error immediately pops up here. In this case, it's indicating that a string is not assignable to the data type number. Essentially, our program or TypeScript is indicating that this string is not valid because we have declared this variable as a number. So what we should do is change this value to a valid number. With this, the problem is solved. So we would always be sending a numerical value to the calculateSquareArea method. If we run this program, we see that in this case we have the number 64 as output. We also have a problem here, which essentially is that TypeScript doesn't know what data type this parameter will have. To solve this, or to indicate that we also want this parameter to be numeric, we can do exactly what we did below. That is, put a colon and the data type we want to enforce. In this case, it is a numeric value. With this, even though we have the same result, we are enforcing that the user cannot send any number as part of this calculateSquareArea method. We are forcing it to only be a numerical data type. So with this, the problem has been resolved. As we have already pointed out in the slides, we can declare other different numeric types. For example, we could declare a variable called color as a number type that is actually a hexadecimal value. For example, it could be equal to 0xFF00. This is a hexadecimal value. We could also house a binary number as part of our variable. For example, we would name the variable bin number equals 0b00110011. This is a binary number already stored in our bin variable, as this variable is declared as a number data type. Basically, this number data type is one of the ones we will use most in our programs. Talk now about the string data type. Basically, this data type will help us to store any text that we can imagine as part of a variable that we declared. Here, we have some examples of these data type declarations. For instance, we have the first representation of a string, which is through two quotation marks. We also have a representation with a single quote, and we have this third representation with a quote, but with an inversion. Basically, with any of these three forms, we can store a text inside a variable, and we will see how to do this in TypeScript. Well, we are back in the TypeScript playground. If you remember, in a previous video, we created a function that performed one side times another side calculation, or it presented the calculation of a square area. Basically, what we print each time we invoke this function is only the calculation or the result of the multiplication of one side by another side. What would happen if we wanted to, at some point, print for the user with more descriptive text? Well, let's create a new function called printSquareArea. Basically, we will send another parameter named side of type number. This we have seen in a previous video. Basically, what we're going to do here is a console.log, like we did before, but with the difference that here we will directly print a string. For instance, square area is. We leave a space, we carry out the concatenation through the assignment or the printing of a plus symbol. This symbol will concatenate two strings, and basically here we can concatenate the result of side by side just as we had before, or as we have at the top, and we basically will comment on this function call and call this new method we have created, passing square side. We will execute this program, and note that this time we are not only printing the value but also the string square area is, and the value, which in this case is 64. Okay, now you may ask, where have we used the string data type that we haven't seen? Well, the truth is that we're going to slightly modify this function to include a string type variable. How can we do this? Well, I will declare a new variable named, for example, text. We will assign a string type data to this variable. The aim of the variable we have declared here is that we can tailor this text to our liking by directly modifying this variable. We will then, for example, put square area is space. This will act as the placeholder for printing the calculations text. With this, we can modify the text to be in different languages, for example, English, Spanish, French, etc. So, once we've created this variable, we'll point out that as part of our function here, we want to add a second parameter named text, which is a string type data. With this, we can modify the cancel.log to, instead of passing this string directly, pass the text along with the multiplication of side by side. Finally, as print square area is now receiving two parameters, we have to pass a second parameter, in this case, the parameter named text. So, with what we've done, if we run our application again, we see that the text remains the same. But this gives us the advantage that we can now modify that text to say, for example, aliases. And if we run this functionality again, we already have this message in Spanish. So with this, or in this way, we can declare a string data type. And we have also seen how we can use this same assignment as a parameter into a function to receive only a string data type, and carry out the corresponding concatenation. Data type we will discuss is called the boolean data type. Essentially, this data type is used to represent either a true or false value. As an example, we have here the two values we can use, either true or false. It's worth noting that in the case of TypeScript, unlike other programming languages like C# or Java, we cannot use a 0 or 1 as part of the assignment to this data type. We can only use explicitly true or false values. Let's look at an example of this in TypeScript. Here we are again in the example we've been creating in TypeScript. What we will do now is declare a data type that is boolean. So let's declare a data type called, for example, isPrinted. We will indicate that it's a boolean data type. Here we can assign either a true value or a false value. However, if we try to assign a 0 value, for instance, we can see that this variable indicates that a numerical value cannot be assigned to a boolean data type. So, as I mentioned, we have to use a true or false value. Basically, we will use this variable to decide whether we want to just print the result or use this second feature where we will print a descriptive text as well. So, I'm going to comment on this second invocation. I will indicate that in the first example this variable should be true to perform a comparison through if. Basically, if you have never used the control statement if, its structure allows us to make a comparison to know whether certain code will be executed or not. In this case, we can compare or simply pass the value is printed, as the if statement only carries out the application on some kind of true or false result. Since we are directly passing a true value here, then this if statement will execute in any given case, or rather, this line or this code within these brackets will only execute if this variable has a true value. As we are indicating this, we will invoke the method that allows us to print the value of our area with a message just like we had here in these examples on the right side. We will pass the parameter square side. As a second parameter, remember we need to pass the text that we want to print, which in this case is stored in the text variable. To specify a contrary case, we are going to write an else. This else will basically execute certain code in the event that this condition is not true. In this case, we are going to invoke calculate squared area, passing the parameter square site. So we are going to carry out the execution of this piece of code that we have written. Click on run and observe that in this first part or this first exercise, if we change this value to false, this will no longer be valid. Thus, it will execute the second part of the code. Let's see if that's true. We go to the tab, click run, and observe that we are only printing the value 64. Essentially, this is how we can use this type of boolean data to determine whether a condition is executed or not executed, among many other cases. The next type we will discuss is the object data type. Basically, this data type will allow us to declare any JavaScript object. Certainly, if you have worked with any REST service or with objects in JavaScript, this syntax will be very familiar to you. Essentially, we will declare a property between brackets, followed by a colon, then the value of that property. In a very simple way, we will be able to declare objects, whether they are complex or simple, to represent certain information. Let's see an example of this in action. Now I'm in the TypeScript playground. As you can see, I've created a new file to start from scratch. We will start by declaring a JavaScript object. Basically, as I mentioned, we have to declare a pair of brackets and then create a set of properties. We have to declare the name of the property we want to declare. For example, it can be name, colon, then the value, for example Hector. We put a comma after declaring a property with its respective value, and then we'll declare all the properties you want. For example, the second property can be called age and can have a value of 23, for example. Here we have a problem, or we have an error, and basically this is because we are not declaring this object to any variable, so we have to declare a variable. Let's then state const. We will name this variable, for example, customer equals, and with this, the problem is corrected. Notice that on the right side, we have a section called .js, and basically this section will give us the representation of the resulting JavaScript file from the compilation. It's similar to what we did with the compilation through the tsc command in Visual Studio Code. Here it is done automatically, and this is the generation of the resulting file. Notice that in reality the code is exactly the same. We have here the representation of a variable with its respective properties and values. However, we have the same problem that we had with the functions. We have a property called name, which we can infer is a types string, and we have a property called age, which we can infer is an integer type. However, here, what I could do is enter a value in string format. Notice that absolutely nothing happens. We have the resulting code. In reality, JavaScript does not know that age refers to a numeric age, because for it, it's just an ordinary property. But we know that age should always be a numeric value. Well, if that is how we have defined it. In this case, or in this example, this is how we have defined it. Age must have a numeric value. So we fall back on the need for some type of typing to avoid confusion when we are creating the program or when we are trying to read the different values, and we find a surprise that we have a string instead of an integer value, for example. Let's then proceed to type this object called customer. How do we do this? Well, first of all, let's separate this equal from the rest of the structure. We leave only const customer. We add a colon and then write a pair of braces to represent each of the properties. That is, within this first set of braces, we will specify the name of the property and its specific data type. For our first property, the property is called name. We want this property to be of data type string. So we write string. We add a comma to separate the first property from the second property. Let's specify what the name of the second property is, which in this case corresponds to the name age. And we indicate that we want this property to only have values of the number type. Once we've done this, we can now reunite these two sections that we previously separated. Now we have the correct definition of an object in TypeScript. Notice that here we have something that TypeScript is showing us about an error. We have an error in TypeScript. And basically, it is indicating that a string data type is not assignable to a numeric data type. This is because we have defined that the age property can only contain numbers, which is why TypeScript is already giving us a hint about what's happening. If we change this value to a value 40, notice that everything is solved. We no longer have any sort of problem. The most important thing is that if we return to the section of the resulting code in JavaScript, notice that the code remains the simplified code. That is, we have nothing referring to the data types that we have declared here, but this has been eliminated. This has to do with what I mentioned in the slides in a previous section. This basically means that the data types are erased or eliminated during compilation to have pure JavaScript code. We can see it here. Here, the big difference is that we, since we are writing the code, have a preview or we have a warning in case we are breaking the rules regarding the declaration of this data type, which is the customer data type. As a final point, if you know that your data type is not going to change or the value that your property has here is not going to change much, then you can eliminate the part that we defined before the equal symbol. That is, your object definition can look like this. However, if you want something more explicit, you can use the form that we saw earlier to specify the data type that will correspond to each of the properties. Later, we will see examples where we will have to apply what we have previously seen. This is how we can use objects in TypeScript. The next type of data that we will discuss is the array data type. Basically, with this type of data, we can define any array that we can define in JavaScript. Here we have a representation where we basically begin with a bracket. We place a series of different values based on the data type that we have specified as part of the array's definition. In this example, we have specified 3 different numeric values and close with a closing bracket. Each of the values is separated by a comma, and we will see an example in TypeScript. Here we are now in TypeScript. We will see how we can create an array in TypeScript. The first thing we have to do is define whether it will be a variable that we can modify or not. We will do this through the const keyword. We need to specify the name of the variable. In our case, we will call it skills. Basically, this array will be an array that will specify the different skills that a software developer has. We need to put the equal symbol and between brackets specify what different values that we will be able to specify as part of this array. We can specify, for example, a series of numbers. And we see that the result of the JavaScript file is exactly the same as we have here. In the case of JavaScript, we can add a string, for example, as part of the array. Note that this is a totally valid code. Here we have the result of the JavaScript file, and we can see that we can then combine different elements. But in the case of TypeScript, as we have previously said, it is a typed language. Therefore, it is important that we can carry out typing of a variable that represents an array, so that it can only contain certain information of certain data types, if necessary. In the case of this variable, skills, we know that we are only going to or need to store text strings. Therefore, we can do what we've done before, putting a colon, the type of data that we want to store, which in this case will be a set of strings. Then write string. Unlike a variable type string, we need to put a pair of brackets to specify that this skills variable will actually be a set or an array of different strings. Immediately, once we have done this, notice that these numbers we had written before turn red. The problem here tells us that the number type is not assignable to a string type. So with this, we are going to remove it so we can only write pure text strings. Here we have added 3 different text strings. We are going to change these strings for programming languages. For example, C# and TypeScript. We see that the result is already valid on the JavaScript side. We basically have a variable with 3 different strings that are valid, and we see that this string and brackets part is eliminated from the resulting part. Another important thing is that we can navigate through the different values of our array using a for loop. We specify a variable that will iterate through our array. We'll call it, for example, skill of skills to traverse the entire array we have at the top. Notice that we can do a console.log of skills to print the different skills found in this array. Let's click run and notice that we indeed have these 3 strings stored in our array. Another thing that we can see is that if we put a period and specify, for example, 2, we have different methods that are available thanks to TypeScript inferring, or knowing what type of data this variable called skill is. Notice that if we position ourselves over skill, we see that skill is in reality a text string. So each one of these values is a text string. As part of the IntelliSense or aid from this editor, we have different methods which are applicable to each of these values. For example, if we were to change skills into an array of integer values through number and specified sets of values, notice if we write 2, we no longer have the same methods that we could apply to a string. This is because it is inferred that this skill variable is now a type of data number. Therefore, TypeScript helps us a great deal to know or to be able to specify which are the different methods applicable for each of the values of our array. One of the things you might wonder is, how can we make a set of numeric values and another type of data, which in this case would be, for example, a text string? Well, in this case, one can apply an array or indicate that this variable is an array of a type called any. However, with this specification, we are leaving the panorama very open to specify types of data to a variable, and basically, we are returning to an untyped language because we are indicating that we can write any value as part of this array. This could complicate things a bit more down the road. Later on, we'll see other types of data we can use to address specific needs. The next data type we will talk about is called a tuple. Basically, this type of data is a fixed length array. Here we have an example. We have an example that is similar to an array. However, you might think this is an array, but a tuple allows us to specify the length or the number of elements that will be part of an array or a tuple that we have previously defined ourselves. You might ask, why would I want to use a tuple? Well, here we are with TypeScript. An example of using a tuple is when, for example, you want to store some kind of dictionary. By dictionary, I mean having a set of different keys or indexes, and then having a value related to that index. For example, suppose you want to store a key called images, and you have a value referencing the file name, for example, emma.jpg. This key actually represents an image. You could have a key called video, and have a video ending with an extension, for example, .mov. This is essentially the use of a tuple in TypeScript, representing an array with different fixed values. Here we have the example. We will proceed to define our dictionary. We are going to use the keyword let to make modifications on this variable later. We will call our variable, for example, file. and we will indicate that the representation will be the same as we indicate in an array. We will specify that as the first parameter or first value of our array, we specify the string called image, and then emma.jpg, for example. Here we have our first value, representing the key or index of our different values, and we have the specific value, which in this case is emma.jpg. If we wanted to modify this file next, we could carry out the modification by placing, for example, a video index, indicating that the files we place on the right will correspond to a video file type. Next, we specify the file name, for example, emma.mp4. Okay, there are no complications up to this point. However, look what happens if I try to add a third value as part of this array that I have represented here. I'm going to add any word, for example, hackerman. Note how we've added a third value to our array, even though the main idea was for us to have only one index or key with its corresponding values. So here JavaScript is functioning correctly. The thing is, if we wanted to type this and impose a restriction on the number of elements that our variable can have, then it's no longer being observed. What we need to do is use a tuple here. How can we represent a tuple in TypeScript? Well, we need to place a colon in the definition of our variable, followed by a pair of brackets, inside which we specify the structure of our tuple. This structure is determined by the different types of data that can be stored as part of the tuple. So we indicate that our first type or our first type of values will be a set of strings, or rather, only string can be housed as the first element of my tuple, and as a second type of values, they will be strings as well. So when we make this change in TypeScript, immediately we have an error here indicating that a tuple type string, string is not assignable to the type tuple string, string. So basically it's indicating that the origin has 3 elements, but the destination has or only allows 2 elements. With this, at the time of code writing, we can identify when we are breaking the rule of this tuple. So what we will have to do here is remove this third piece of data from our array or our tuple, and this solves the problem. This is a practical example of when we could use a tuple in a real application. This is the basic use of a tuple. We continue with predefined data types. On this occasion, we will look at a data type called enum, which, like a tuple, is a data type that comes as part of TypeScript. JavaScript does not know about these data types. So let's look at the enum data type. Basically, the meaning or description of this data type indicates that it allows us to carry out the declaration of constant global enumerated identifiers. The definition might sound a bit complicated, but it's really very simple. Basically, it suggests that we can use the keyword enum, followed by a pair of braces, and within these braces, we can start defining a set of different elements for use within our application or program. Actually, the usage is very straightforward. So let's look at a practical example in TypeScript. Okay, now we are in TypeScript. Let's assume that as part of our application, we need a variable that allows us to store the preferences or different settings that a user has stored as part of their account. Then we will quickly declare a constant called preferences. This will be equal to, inside this variable, we will specify an object, which is a data type that we have already discussed. We will indicate, for example, that the user can store the font size in the application, that they can store, for instance, the family or font that can be used as part of this application. So let's use Times New Roman, for example. Lastly, they can save a color that stands out in the application. For example, one way to store this information might be using numbers. For example, using 0 to represent red, and using 1 to represent yellow, and so on and so forth. However, this is quite inefficient, as remembering each numeric value for each color can be somewhat complicated. So a second option could be that you might think you can use a set of strings, for example, red to specify a red color. Let's just leave this object as it is for now. For some tests, suppose we carry out a comparison of the property called color, equal to whatever part of your application you specify. Well, I remembered it was red, and you write it that way. What is the problem with this? Well, let's do a console.log and color red. If we run this application, we see nothing appearing in the logs. The problem lies in that we specified the comparison with a lowercase r, while it was declared with an uppercase R. This could cause us some errors, when we perhaps think we are making a correct comparison, but in reality we are not. So you could choose to declare some variables that would allow us to store the value directly with the name of the variable itself, so we don't have to recall the exact string. So you might think, well, I declared a constant called red with a value of 0, a constant for the color blue with a value of 1, and a constant for the value green with a value of 2. Suppose these are the three elements we are interested in storing as part of the preferences or user settings. So with this in place, we could replace the string with a variable. Notice how IntelliSense immediately reminds us of the name of this constant. For example, let's assume we store the color red for the variable preferences, and now we can compare in a simpler way with the color red, which has a numeric value of 0. Okay, this is fine, and in fact, if we run this application, we can see that we already get the red color message. Therefore, the comparison is being carried out successfully. This is correct up to a certain point. Well, it is correct, but managing these variables can take some time and can also cause us certain problems if we have to declare many variables to store different values. Therefore, this is not optimal. There is a better way to do this, and this method is called enumerations. Basically, we are going to declare an enumeration so you can see how it's done. You just have to write the keyword enum, followed by the name of your enumeration, which in this case we'll call, for example, colors. Then, between the brackets, we'll specify the set of values that we want to store. In this case, the values will be red, blue, and green. So we write red, blue, and green. We place the semicolon, and now we have an enumeration with these values we have here. Therefore, these variables or these constants are no longer necessary. We can eliminate them. Now notice what happens here. In this case, we only have to remember the name of the enumeration to place it as part of this color we see here. We can write colors, and you see we have a data type with this symbol we see here, which, if we press a dot after this word, the different elements that correspond to this enumeration will appear. Therefore, we can complete the type, or rather the value of the enumeration red, and also carry out the comparison here with colors.red. We see that reaching the red value is much easier, and if we execute the application, we find that once again the phrase color red is printed, which leads to a positive result. Okay, let's position ourselves over each of these values, and you can see that we have assigned a value for each of them. We have the value 0 for red, the value 1 for blue, and number 2 for green. We could modify the element. For example, we could assign the value 10 to red. You can see that the subsequent enumeration values start incrementally from the initialization number, which in this case was 10. With this, we can adjust the behavior or simply change the enumeration values. Here, we could change the value to 20 for blue, and green would then have a value of 21. As part of an enumeration, we could include a text string. For example, if we needed to store a hexadecimal value as part of the enumeration, we could assign a string to the red enumeration value, which could be the red color's hexadecimal representation. For example, we could replace this 20 with a hexadecimal number. I'm going to remove this equal sign. In the case of the blue color, this is a hexadecimal representation. For the green color, I'll copy this text and modify the hexadecimal number. Once we have done this, we could directly print the corresponding text string for the color red instead of console.log colors red. You'll see what happens. We can print the text string relating to the red color, which we could then use, for example, to color a graphic element that is part of our web application. So essentially, this is how enumerations are used. It is also widely used to carry out, for example, the role assignment part in an application, to compare whether a user is an administrator or a user, and this can be done in a very simple way. This is the use of enumerations, and we see that it is quite simple. The next type of data we're going to talk about is called any. Basically, the definition of this type of data is that we can hash any type of value as part of a variable declared with this type of data. That is, we can store a value of 1 or a numeric value, whether an integer or with a decimal point. We can store strings, we can store true or false values, that is, boolean values. That is, it is a type of data that allows us a lot of flexibility, but we must be careful with its usage, since by using it, we are essentially returning to a similar use to JavaScript, where we don't have much control over the types of data we use in variables. Let's do an example of this type of data. Now we're back in TypeScript. Basically, as I was mentioning, we can use the any data type to store any value. Let's declare, for example, a constant called number1. As you will remember, if we assign it a data type of number, we can assign only numeric values, whether they are integers, decimal values, negative values, etc. But if we try to use a text string as part of assigning this type of data, we basically had an error. If we change the data type from number to any, we see that this value or this error we had completely disappears, and we can then use a true value, a zero value, a string type value, etc. This is the flexibility that the any data type gives us. Similarly, if we declare a function, we could previously indicate that the parameters could be numeric. For example, I'm going to declare a second parameter that is also of a numeric type. Basically, here we could do any type of operation. For example, return the multiplication of number 1 by number 2. If we had specified the data type of the parameters as a number, we could not send a different type of parameter, such as a string, to this function. Note that here we have a problem, indicating that the data type string is not assignable to a data type number. However, if we change the data type to any, we see that this problem disappears. So this is the use of the data type any. Remember to be very careful when using it or when you really don't know what value you are going to expect from a certain operation. Therefore, we have to be cautious, and this is how to use the data type any. There will be occasions when you will need ways to compose or combine different existing types instead of creating your own. Intersection and union types are one of the ways to accomplish the composition of different types. Let's see how to do this in action with TypeScript. Assume you need a function that allows you to add different numbers and also concatenate different strings, all with the same functionality. We will create a function called, for example, merge, which will accept a first parameter. Since we need to receive both numbers and strings, we could think that we can use the any data type for the first argument and the any data type also for the second argument. what we will do is a console.log to perform a sum operation with the second parameter. So we have a very simple function. However, when we call this function, we can pass a first string and a second string. For example, if we run this function, we see that it returns this string. Also, if we pass a number as the first argument and a second number, we get the expected result. However, if we try to pass a boolean value true for both the arguments, we get an unexpected result because it is printing a 2. This should not be valid. TypeScript should warn us that we can't do this because we are working with boolean values. However, since our function has a couple of arguments of the any data type, that's why this is valid. For example, we can indicate if type of first equals, this signifies whether the variable or parameter named first is of type number. Then we can perform a second comparison to make type of second equal to and again number. That is, if both the first and the second parameters we are receiving as part of the arguments are of type number, we can add these two values together. Notice that the error we had earlier disappears here, because TypeScript is now detecting these as two numeric values. We can create a second comparison if, in this case, the first condition is not true. Then we can compare if first is equal to a string and the second parameter called second is also a string type. In this case, we can perform a console.log to carry out the concatenation. We can perform the conversion of the first data type to a string with the toString method, and concatenate this with second.toString to force the value to convert to a string. This way, we can perform concatenation if they are a pair of text strings. So with this, we are successfully performing the combination, or rather the concatenation of two strings. In case the user persists in sending incorrect data, we can throw a new exception through throw new error and include a message such as bad arguments. Okay, so here we validated that we are sending a pair of correct parameters, in this case a pair of strings. Here I forgot to insert a type of. We need to add it to each of our comparisons, otherwise we won't get any kind of result. Okay, so let's run this application, and you will see that we are successfully receiving the hello world message. If we change this to a numerical value and this to a numerical value as well, we will get the sum successfully. In case the user insists on sending a value that is not numeric, for example, if we have the receipt of a couple of boolean values, let's see what happens. We run the application and see that we have an error here, indicating that the boolean argument is not assignable to a parameter type string or number. We have nothing else. However, if we go to the developer tools, we see that we already have this error, which indicates that we have an invalid set of arguments for our function. So this is how we can use unions to expect more data types. In fact, we could use this type of unions for other things too. For instance, we could declare an array called, for example, data. And as you might remember, if we specify, for example, number and a few brackets, we indicated that it's an array, so we can then start to input numbers. However, as you might remember, there are times when you might want to add a different data type as part of your array. In this case, the error message indicates that the data string type is not assignable to a numerical type because the array is defined as a number. In this case, we could create a couple of parentheses instead of the number we had declared earlier and specify what types of data we want to receive as part of our array. In this case, we can now accept a numeric data type and a string data type as part of the array. If we tried to input a boolean number, we would encounter the same problem. The issue is that a boolean data type cannot be assigned to this kind of array. We could potentially solve this by adding the specification of the data type we want to use, which in this case is boolean, as part of our array. This is essentially how we can use union data types to receive more than one type of data as part of the different actions we are trying to perform. Let's now look at literal data types or literals. A literal is a more concrete subtype of a collective type. What this means is that a hello world is a string, or the string hello world is just that, a string. But a string is not a data type called hello world within the type system. What I want to say is that, for example, if we carry out the declaration of a variable named hello, which equals hello world, we see that if we look at the data type of this constant, we can see that it's not a string, but a specific type called hello world. That is, this hello world string is a string, but the data type string as such is not of the type hello world. Let's look at another example. If we, for example, look at a variable or declare a variable named number1, which equals 1, we see that number1 is of a specific type 1. Here we have it. We don't see that it's of the type number. If we specify this through a colon and number, we see that this definition changes and that number1 is actually a number. This seems a bit confusing, but we will understand it better when we see the examples. There are three sets of literal types available in TypeScript today: strings, numbers, and boolean values. By using literal types, you can allow an exact value that a string, a number, or a boolean data type should have. Let's start with an example of string literals. In practice, string literal types combine very well with union types, type guards, and type aliases. You can use these functions that we declare to get behavior very similar to a string enumeration. Let's take a look at an example. Suppose we need to carry out some kind of processing, but while limiting the use of a certain browser. We will proceed to declare, for example, a new function called process, which receives a variable named browser. But we only want to be able to accept two specific literal text strings. For example, when we use a browser named Firefox, and also, through the unions we saw in the previous video, a string named Chrome. Okay, notice that we are not declaring the data string type as part of this parameter we are receiving here, but we are indicating that it can be either of the Firefox type, which is a specific literal string, or a subtype of the data string type, or a string named Chrome. Based on this, we can conduct certain behavior. For instance, here we can execute a console.log valid browser. Okay, if we invoke this function from another part of our code, we see that we can use the literal string Firefox, and if we run the program, we see that we get the corresponding output. If we use the Chrome string, exactly the same happens. However, if we try to use a different browser or try to pass a different literal string, we see that we have a problem from TypeScript, telling us that Edge does not correspond. It is not assignable to a parameter of type Firefox or Chrome. So, this is how we use string literals to carry out some kind of validations directly on a functionality. Let's take a look at another example, but this time with numeric type literals. Suppose that we need a function called fight. Suppose we're developing some sort of video game, and we need to ask the user to select a difficulty level. Well, we can declare here the parameter called difficulty. And we can assign some valid numerical values, for example, level 1, level 2, and level 3. So, based on this, we can conduct a console.log to initiate a battle. Let's comment on this line. And we will proceed to write a second line where we are going to call this method called fight, and we will indicate that we wish to pass, for example, difficulty level 3. And with this, we see that we can already execute this method effectively. However, if we pass an argument that is not valid, then we have here some kind of problem, because we are trying to pass a number that does not correspond to the different assignments or different literals we have declared as part of our method called fight. We can also do this with boolean values. However, this involves a little more complexity, as it would not make much sense to be able to declare here a true and a false, as these are the only two values allowed as part of a boolean data type. This involves a little more complexity when using certain types of more personalized data. We will talk about this a little later, but basically this is how we can use literals to carry out some type of restriction based on certain specific information from the data types. Let's now talk about type aliases. Basically, these aliases will allow us to represent in a simpler way the various unions that we create. So far, we've used unions this way, that is, by specifying the exact values as part of the receivers of our methods, like we see here in this example, in this line or in this first line we have here. However, we can also declare the types to be able to use them or reuse them later in our applications and not have to keep writing the definition of each union we make time and again. How can we do this? Well, we have a specific keyword that will enable us to carry out this task. If we write the keyword type, we can define a data type that allows us to define different unions. We can name this type of data any way we want. For example, let's write browser. As part of our initial definition, we will assign different value literals that we want. For instance, if we want to use these two literals, we will cut this part from here and paste it. Now we have a new data type called browser, which will store either of these two literals. Once we have this, we can indicate through this definition here that the data type browser should be of a data type browser that we defined earlier, having either of these two values. If we implement the use of the process method, we see that it maintains the same behavior. That is, it does not accept the word Edge, but it does accept the word Firefox and also the word Chrome, as we see here. We can do the same with the second definition of this union. We can indicate type fight options is equal to, and we can cut these different values that we have here. Once we have done this, we can specify that the parameter named difficulty will be of the fight options type. We see, therefore, that this remains totally valid for the use of our function. We have here the invocation of the fight method, but passing one of the possible values. If we pass an incorrect value, we already have a problem here. So these types we can reuse them later on, and we can perform other tasks with these types that we have seen here. Let's see how we can use functions as types. To demonstrate this, let's begin by creating a couple of simple functions. We'll create our first function named calculateRectArea. Basically, this function will allow us to calculate the area of a rectangle. We need two parameters. The first parameter, called base, will be of type number, and the second parameter, called height, will also be of type number. Simply put, our function will return the multiplication of the base by the height. Then we'll declare a second function called printArea that will enable us to print the result obtained from the first function. We'll specify that it accepts one parameter called result, which will be of type number. What we'll do here is use console.log to print result, followed by a space, and the result, or the parameter we're sending as part of this print area method. Okay, we have our two functions set up for our demonstration. Let's assume we define a variable named calculator. If you've worked with JavaScript, you'll know that you can assign a function to a variable, or create a pointer to a function and assign this pointer to a variable in your JavaScript code. That's what we'll do next. We declare a variable named calculator. Then we'll have calculator equal to calculate rect area. As you can see, we're assigning a pointer to the calculate rect area function to the variable named calculator. If we do a console.log directly from this variable that we've declared, we can pass here the base, like number 2, and the height, like number 10. And if we execute this program, the operation returns a satisfactory result as expected. However, we have a small issue here. Once we've assigned the pointer to our calculator variable, we could assign any value. For instance, a string, any text string. Notice that we'd already encountered an issue in TypeScript. However, if we execute this function, we see that we get no output in the console. However, if we go to more tools, developer tools, we see that we actually have an error message that tells us calculator isn't a function. So, although TypeScript warns us of this, there might be a scenario where we perform this operation and execute something that's incorrect. How can we solve this? Well, one of the possible solutions is to specify that this variable can only accept functions as part of the value assignment. This is achieved by declaring this variable with a colon and using a special type called function. Essentially, this limits the calculator variable to accepting functions only. As you can see, we now have an error issued by TypeScript because it tells us that string type isn't assignable to a function type. With this, we correct or solve this issue. If we run our program again, we see that we get a satisfactory result. Okay, it seems like we solved everything. However, I want to show you that there's still a small issue. We could assign to calculator the function called print area because it can accept a function as part of the variable assignment. Note that we don't have any issues in the TypeScript editor. In fact, if we run this application, you'll see that we already have two logs here, one that says result2, and then we have this undefined message. This then makes our program behave in a strange way, because it is indeed printing some kind of result, but it is also giving us an indication that everything is not running satisfactorily. The problem with this is that we are not limiting what is the structure that we want to run as part of our application. Basically, we could limit the assignment of this variable to have a certain structure in the function, so that only when executing this structure, we would not have any type of problem in this console.log. How can we do this? Well, we are going to use a function type, which is a special type of TypeScript to carry out this functionality. Basically, it's very simple to use. After the colon, we will indicate a pair of parentheses, and equal symbol, and a greater than symbol. Once we have created this type of arrow that we see here, we are going to proceed to indicate which is the type of data that we want to expect from a function. As you can see, what our function does is to perform a data type. If we hover over calculate rect area, notice that here as part of the return of this function, it tells us that we are receiving a number or a number data type. We know this because we have here the signature of our function. We have here this colon and later the type of data that this function is going to return. So we indicate that we expect a number data type. With this, we already have here ready the variable that indicates me that we are waiting for a function that returns a number. But inside these parentheses that we have here, we are going to be able to specify which are the parameters that we receive or that we are going to wait to receive as part of the function. Right now, inside these parentheses, we don't have anything, which means or is equivalent to us having a function without any parameters, that is, a function similar to this. We want to, or if we have a couple of parameters, we want to receive. The first parameter is of the number type, and the second parameter is also of the number type. Therefore, within those parentheses, we are going to specify the name of the parameter. I'm going to designate it, for example, B for base. We need to specify the type of data we are expecting, followed by a comma in case we have more parameters, and age. I'm going to put an age representing height, followed by a colon and the word number. These letters that we have here can really be whatever you want. It could even be the complete name of height. There is no problem at all. The only thing you need to make sure of is to have the correct number of parameters for the function you want to specify. Note that with this line that we have here, line number 12, now shows us a correct line because it indicates that I am assigning a function that meets these requirements that we see here. That is to say, having two parameters, both of type number, and returning numerical data. Note that in the case of line number 13, we have a problem here because it basically indicates that this rule is not being followed. Here, our function defines only one parameter that receives a data type number. However, this function does not return any data. Therefore, this assignment is totally incorrect. If I remove this line, we see that we no longer have any errors as part of our application and we are already printing a completely valid number. With this, then we could carry out the definition of some additional functions that had this signature, and we could assign these functions to this variable calculator, in case they had a correct signature, without any problem. Let's talk about callback functions in TypeScript and how we can use them to carry out certain actions that we need after some processing in our functions. We will start by carrying out the writing of a very simple function called process. In this case, this function will be responsible for carrying out the sum of two numbers, but we want that after carrying out the sum of these two numbers, it carries out a certain action. Therefore, we will indicate that we need a pair of numeric parameters. This causes us to do the usual thing, n1 plus n2, that is, the sum of these two parameters that we are sending as part of our function. Here we can create a return to indicate that we are returning the sum of these two numbers. However, we said that we need to carry out some processing after carrying out the sum of these two numbers. We can do this thanks to something called a callback. If you don't know, a callback is a functionality that you can execute after carrying out a certain task, as I have already told you before. In case of our function, we will indicate that we want to accept a callback, which is a function. To explicitly indicate that we want, we can specify the structure of the function type that we want to receive as part of this callback, or what will be the signature of our method that we want to implement so that we can carry out certain processing. In our case, imagine that we need to carry out the pass of the result of these two numbers. This results in a single number. Therefore, we can specify here result number. Remember that between parentheses, we are indicating what is the input number or what is the input data of our function. Subsequently, with the equal and greater than symbols, which create an arrow, we will indicate the return type we want for our function. This could be any type of return, but I will teach you one that we have not seen until now, or that JavaScript does not have as part of the language, and that is part of the TypeScript language. It's called the void data type. Basically, this data type serves for us to be aware that nothing will be returned as part of this functionality. Even if you create a function that only has, for example, a console.log, you will see that the return type, let's do it quickly, let's do this, function test. Notice that if we position ourselves over the function, we see that we have void as the return type, which, as I said, is exclusive to TypeScript. Other programming languages like C and C++ have this type of data. However, it does not exist in JavaScript. So, as you can see, since this function does not return anything, we have this return type. So, as part of this function that we declare here, we indicate that we receive a parameter and that we return a void element. Once we have done this, we can perform other actions on this result. For example, we will store this result as part of a new constant called result. And subsequently, we can invoke the callback that has this structure. Note that it will receive a number. In our case, we will return the result, or we will insert the result on this function or this callback that we have here. You might ask, well, where is this function or this callback that we indicated here that we want it to execute? That is, what will be the next task that will be executed once we have the result? Well, we will do that once we have defined the function and want to use it. For this, we simply need to invoke the function. Let's pass, for instance, two numbers, number 10 and number 10. Notice that as the third parameter, it is already expecting this invocation, a function that is part or that has this signature that we see here. So here we can pass an anonymous function. For example, here we can specify that the input data will be called X. This data can be any data you want, with an arrow symbol like the one we see here, and then a set of brackets. We will specify the functionality of this method that we are declaring and is the one we are passing as part of the callback we see here. That is, this function that we have here basically has the same structure as what we've said so far. It receives an input parameter, and in this case, as this functionality is void, nothing will be returned. As you can see, once we have carried out the processing of each necessary line, we invoke the callback. This is where the code that we write within this invocation will be executed. In our case, we can do anything with this result. For example, a console.log of the result. In this case, the variable is called X, and that's why we have to pass the X. If we finally carry out the execution of this functionality, we see that we have successfully printed the number 20, which is the sum of 10 and 10. So this is basically how we can use a callback in a function. Recapping, we have to specify as part of the function that we want to pass a callback. Within the parentheses, we specify what are the parameters we expect in a function and what is the type of return data. Afterward, after we carry out the processing, which can be one line, it can be 10 lines to obtain some results. There are times when we need to declare a variable without really knowing what data type it will contain. Usually, this information comes from dynamic content, like, for instance, user information, or perhaps we create an API that accepts all possible values in the same way. In these cases, we want to provide a type that tells the compiler and future developers that the variable can be anything. We can do this thanks to the data type known as unknown. Let's see it in action. To declare a variable of this type, we simply write the variable name, such as user input. We must specify the special data type called unknown, as shown here. We can assign practically any value to this variable. For example, we can assign it a value of 4. Later, we could assign it a text string, or we could assign it a value such as false. All these inputs for this variable are actually valid inputs or valid values because that is what this variable or data type allows us to do. You might ask, isn't it the same as using the any data type? Well, it might seem that way initially, but let's look at several examples in which the behaviors of an any data type and an unknown data type differ. The first difference is, for example, if we declared a constant called number1 and assign it a specific data type like the number data type, and we assign it something like user input. Notice what happens. Here it is already showing us an error, indicating that the unknown type is not assignable to the number data type. So that is one of the first differences. If we change the data type to any, notice here that we could assign this variable to the new variable that we've declared. So it's one of the first differences. Another thing that the unknown data type allows us to do is to carry out certain validations to make sure that we're working with a specific type of data. Upon validating or falling into this validation, we'll be able to carry out some operations on the specific data type, which in this case is the unknown data type. What I mean to illustrate this practically instead of theoretically is if I conduct a validation for the data type user input, meaning if I specify the type of user input to be equivalent to a numerical data type, check what will happen with this line I have here. I have made no modifications to it. I paste it within this validation. TypeScript no longer marks any kind of problem. This is because we are directly validating the data type user input. That is, we're ensuring that even though it's an unknown data type, by performing this validation, we're making sure that the user input data type is actually a data type that holds a numeric value. Therefore, we can now conduct some operations directly on this data type. With these validations, we can confirm that it's about specific types of data. Although it is recommended to perform unions to validate that it's about specific types of data. The more specific we are, the better it is. However, if we had to use the unknown data type, or if we had to choose between using the unknown data type and the any data type, it is advisable to go for the use of the unknown data type, since, as we saw during code writing, it limits us a bit more on what we can do with data types and obliges us to carry out such validations. There is a data type called never that allows us to represent the type of values that never occurred. I know it sounds a bit strange, but to give an example, never is the return type for a function expression or an arrow function expression that always throws an exception or one that never returns a value. Let's look at an example. Suppose we have here a function that will allow us to carry out the deployment of some type of error message on the console. We will indicate that we want to accept a parameter of type string, okay? This function will launch a new error with the message we sent. We now have our function ready. If we position ourselves over the function named error, we see that this function is returning a void data type. Indeed, this function, as you can see, really will never return anything to us. This is because the flow of the application is being interrupted at some point. That is, the flow is interrupted and, therefore, if we had here any additional instruction like console.log message, for example, notice that here TypeScript itself suggests that this code can no longer be executed because an exception is being thrown. For this type of functions, we could use the never data type, which indicates that this function will not return anything at all. We can create here a second function that calls to this first error function with a message, for example, internal error. Notice that the data type of this function is a never return type, meaning that this function will not return anything either, because this first function does not return anything. Another use or another example of this kind of functions is, for example, if you had a function named infinite loop, and basically this function did not have any kind of return because it is a function that runs infinitely, for example, through a while loop, with the value true as part of the condition we want to execute for this cycle. Here, this function would be an excellent example to also apply the never data type to indicate that this function really will never return anything because it's an infinite function that will be running again and again and will never return any type of value unless its behavior is modified with code. Then it would no longer be a never data type, but it would be another different type of data in return. So basically that is the never data type. In this section, we're going to learn how to set up our TypeScript-based projects using Visual Studio Code. So far, we have been doing different tests within the TypeScript website itself. However, it's convenient for us to manage several files for more complex projects, and this requires having different TypeScript files as part of a project. So in this module, we'll learn how to set up our various projects for automated compilations and also how to adjust the configuration files. Okay, previously in an earlier video, we saw that if we create a file with a .ts extension, we could compile it with this command we see here, tsc, followed by the file name, which in this case is helloworld.ts. This is what we need to do currently if we want to compile the file into a resulting JavaScript file. This isn't as good or flexible if we have larger projects with many TypeScript-based files. Even the fact of creating this compilation manually, having to write tsc and the file name can take up some time. In this video, we'll learn how to do some sort of monitoring so that any changes we make in the TypeScript file are reflected or are compiled in a fast and simple way. To do this task, we simply have to write the command tsc followed by a space. We have to write the file name, which in this case is helloworld.ts followed by a space. Next, we can write a hyphen followed by a w. This w represents watch. What this means is that we can monitor file changes at save time, and these changes will be executed or compiled automatically. Let's press the enter key. As you can appreciate in the terminal, we see that the compilation starts in watch mode. Okay, pay attention to what happens here. We have the output of the file hello world. We see the output in the helloworld.js file, and we see that we have practically the same code. However, if we try to make any changes, for example, removing the exclamation mark and adding 3 dots at the end of the string, see what happens if I save the file. I press Ctrl S, in this case, if we go back to the helloworld.js file, notice how these 3 dots have been added immediately, but in reality, what has happened is that an automatic compilation has taken place, as we are running our program in watch mode. Okay, this is a pretty good solution that can help us monitor changes in TypeScript files. However, we still have the problem that this monitoring will run on the same file. For example, if we try to add a new TypeScript file and add some kind of code here, a cancel.log for example, we save the file and notice that this time the file corresponding to this TypeScript file has not been generated, because we have only added the watch conditional for the helloworld.ts file. Next, we will see how we can carry out a compilation on our entire project on the different files with .ts extension or TypeScript files. If we want to perform monitoring of multiple TypeScript files as part of our project so that compilation is performed on each of them, we have to perform initialization of our project, that is, add a configuration file for the project, so that the compiler knows exactly what it is going to do with each of the files that are part of our project. To carry out the addition of this configuration file, first we have to have this monitoring by pressing the Ctrl+C keys, and with this we exit or stop monitoring the file and return to our terminal to be able to write commands. To carry out the initialization of this project as such, so that it can accept this configuration file, or so that it is created automatically, we will type tsc from the TypeScript compiler, and we will proceed to add a double hyphen, followed by the keyword init, as it appears here. I'll make it a little bigger so you can see exactly what this command looks like. Press the enter key and see what will happen. Here we get a message saying that a configuration file named tsconfig.json has been created successfully. We have here basically this file called tsconfig.json with different features or different options. Some of them are enabled, some of them are not. But basically what this is going to allow us to do is to carry out the compilation in a faster way of the TypeScript files. For example, if we type the tsc command without typing any other parameters, see what happens. I press the enter key and each of the JavaScript files corresponding to the TypeScript files are successfully created. So basically this file allows us to carry out the configuration of the project, and it is a good idea that you know about the parameters available in this file. Similarly, and before concluding the video, if we want to now monitor changes in the TypeScript files through the watch command, we can simply write tsc-w. Note that when you initiate compilation, for each of the TypeScript files, I'm going to delete the JavaScript files to test this. Watch what's going to happen. I'm going to modify this first file, I'll add another point, save the file, and notice what has happened. The corresponding JavaScript file has been automatically created. In the same way, if I modify the app.ts file and save it, similarly, the JavaScript file is created automatically. Therefore, with the configuration file, we can also monitor each of the TypeScript files to view different changes and generate a new JavaScript file from the TypeScript file. Once we have created the configuration file for our project, we will proceed to analyze some of the most important features or options that are part of this file and will be useful throughout this course. So let's open the tsconfig.json file. The first thing we can notice here is that we have a guide, or rather a URL, that will allow us to read important information about this file or read about each of the features that are part of this file. Let's open this URL to see what is displayed. Essentially, it is a reference to the tsconfig configuration file. We have different sections here, and we'll see what each of the options serve for, or well, the most important options of this configuration file. Let's start then with the options that aren't commented. If any are commented, I'll quickly teach you how to use them, if I consider it important. Let's start with this option that is called or says target. It states that this option allows us to specify the target version of the ECMAScript. These different versions of ECMAScript basically refer to some introductions of changes in JavaScript language itself. For example, if we open the browser and search for ES6 what is, notice that the first link of W3 Schools tells us that basically the ECMAScript 6 version is the second major revision of JavaScript. What these revisions do is often introduce new features to the language. For example, we see that in the case of this ES6 version, we have the introduction of keywords like let, the keyword const, which are words we already used in previous videos. Here we have other features that have been introduced to the language and can be used as part of this ES6 version. If we use an older version of ES6, these features will not be available. We will make a test in this regard. Notice that currently the target is specified as ES5. I'm going to test with the helloworld.ts file. Here I'm going to declare a constant named, for example, number1. It will be a numeric type. I will set it equal to 10 for instance. Then save the changes. Now let's check the file. Notice that in the resultant helloworld.js file, this variable is declared, but with the keyword var. That's because we are using the ES5 target, which in this version neither provides the const keyword nor the let keyword. If we return to the configuration file and change the version to ES6, then save this file, we can proceed to save this file again. Notice that the var word has now been replaced with the const keyword. So this part of the target helps us achieve or maintain certain compatibility with browsers. If we want to target browsers that have been around for a while, you might find it useful to use a definition older than ES6. However, if you want to target modern browsers, well, you can use ES6 as the target of your application. So basically, this is what the target is used for and how you can change the behavior or modify the output of the JavaScript file according to the version of the language you want to use. As part of the configuration file, we also have an option called module. We will leave this option for later. We also have a commented option called lib. Basically, these lib options allows us to specify a library of files to be included in the compilation. And this option, which we will review in this video, allows us to examine the documentation and note that here we have the description of this option. It says that TypeScript includes a default set of type definitions built for designing JavaScript applications, as well as some additional libraries for working with browser environments. For example, for working with the document keyword or with the DOM of our web page. Basically, it tells us that we can change this behavior in case we have some specific cases where we do not want to use this type of behavior or some specific type of functionality that comes by default in TypeScript. Like, for example, if our program does not run in a browser, then we do not want DOM definitions as part of our program. This makes a lot of sense because if we create an application for a server, then it's basically pointless to manage the DOM of our web page or try to make modifications if we aren't interacting with this DOM tree as such. Let's see a practical example of this. We will examine the file named, we will examine the helloworld.ts file. Let's create a quick variable here, for example, text, that is of string type. Notice that as part of TypeScript, we can use this specific type called document, which will allow us to interact in some way with the DOM of our web page. We can use a method here such as getElementById. We can specify that we want to obtain an element with the ID name. We want to obtain the inner text, for example. Here, as part of TypeScript, it indicates that we have a small issue. We will quickly resolve it by inserting a downward exclamation mark. With this, our problem is solved. We will cover more about this later. Don't worry about it at the moment. What I basically want to say is that we have some functionalities or some libraries here already preset to work with elements, with basic JavaScript, for instance, with the DOM as we saw in the previous example. What would happen if we go back to the configuration file and enable this part or this component or this configuration option lib? Okay, let's see what happens. Let's save this file. We go back to the helloworld.ts file and see what has happened. We have a problem here that basically tells us that the name document can't be found. That's what is happening. Well, here it suggests that we could try to change the lib compiler option to include this component, which is the DOM. Let's do it and see if this is true. As part of this array of different capabilities, we can add in the quotation marks and see what happens. We have different options that we can add as part of these features. We're going to add this configuration called DOM, which will allow us to work with the DOM tree. Let's save the file. Notice that this error disappears instantly, assuring us that we can now work with the DOM tree. This is basically how the lib configuration file works. Here we can add different libraries as we need them. We can also remove features that we don't need. Well, by enabling this option. If we disable this option, the default parameters come to the rescue, and we have here again the valid configuration file. We will continue analyzing various options of this TypeScript configuration file. We continue with the option called allowJs and see that it is currently commented. Basically, this option allows us to compile JavaScript files. As part of our application, we could have a set of files in JavaScript format, which are not related to TypeScript. We could, with this configurator or with a TypeScript compiler, compile these JavaScript files without needing a TypeScript file. This is useful, for example, if we need to migrate any type of application, and we do not want to conduct an immediate conversion of any JavaScript file to a TypeScript file, then this option would be very useful. Similarly, when working with JavaScript files, we have this option called checkJs, which basically, as this option implies, allows us to carry out error validation in JavaScript files. I repeat, these files have nothing to do with the TypeScript files we have seen so far. We also have an option to allow the specification of code generation that has more to do with the React framework. At this time, this option does not interest us, and we have another option called declaration and declaration map. This basically allows us to generate .d.ts files, and the second option allows us to generate a code map for these types of files. You might wonder, what do these files ending with the extension .d.ts do? Well, basically, these are files that provide typing information about APIs written in JavaScript. For example, if you used a framework like jQuery, a very known JavaScript library, you might want to use it from TypeScript, but without needing to rewrite all the code in TypeScript. So what you can do is write only a file with an .d.ts extension, and this should contain type annotations so that we, from the moment we write code in TypeScript, can enjoy all the benefits of using TypeScript. In other words, validations at the time of code writing, to see if certain code is correct from the time we are writing the code, and not wait until the compilation of the file takes place, or rather, the execution of the file, for it to fail when it is running. Instead, before we run the application, we should know if a file is going to cause conflicts with a framework or with a specific JavaScript file, or if it will be a correct file. This is what files with a .d.ts extension are used for. Subsequently, we have the option called source map. Its description indicates that it allows us to generate the corresponding .map file. What does this mean? Well, let's make this a bit more demonstrative. We will proceed to create a file. Let's call it, for example, index.html. Okay, now that we have this file ready, we will use a template by writing HTML. Notice that we have different options with autocomplete. We select this option with 2 dots followed by the number 5. Notice that this fills our template for a valid HTML5 code. We will proceed to include the file that we have been generating called app.js as part of the header. Remember that in a TypeScript program, or rather in a web application, you cannot directly include TypeScript files, because basically your web server will not recognize these files as such. So we will include the JavaScript file. We will do it through the script tag. We will indicate that the source is equal to the file called app.js. We close this tag. With this, we can right-click on the HTML file. We can click on the button that says Reveal in File Explorer, and this will send us to the folder where this file is located. I will proceed to open this file, which is an HTML file. Let's open it in the browser. Once we have done this, let's go to the Developer Tools. Here in More Tools, Developer Tools. We go to the console. Notice that here we are printing the successfully message that we had in the TypeScript file, which is basically what this app.js file does. It does a console.log of the word hello. Okay, let's go to the debugger part. Notice that in this section, we only have two files, the HTML file and the JavaScript file with the .js extension. We just have these two files. But what would happen if at some point you want to use the TypeScript file for debugging? For instance, if we position ourselves now in the JavaScript file, we can set breakpoints here to conduct some analysis. As I mentioned, what would happen if we wanted to use the original TypeScript files for step-by-step debugging? Well, this is possible thanks to this option that appears in the configuration file called source map. Let's test how it works. I'm going to uncomment this line of code. I'm going to save this file. I'm going to modify one of the files, or well, it just did it automatically. Notice that the compiler automatically generated files consecutively, ending with the .map extension. Let's open one of the files to see what's inside, what these files look like. Notice that we have some features of this file here, such as its name, the source root, sources, names, mappings, and fundamentally, these types of files will allow us to carry out the debugging process linked or tying to the TypeScript files. Let's go back to the browser. Let's refresh this page. Notice that at this moment we now have, apart from the original JavaScript file, the TypeScript file included here as well. Notice that we can open this file and we can see the content of this file as it appears here. And we can also perform some actions, such as setting breakpoints. I'm going to do something slightly different. I will go back to app.ts. I will declare a variable, for instance, let x number equals 3. Then I will indicate that x equals 10, for example. Alright, I will save this file. Let's check that it generated correctly. Here we have it. We return to the web page. We will proceed to update this file. Let's position ourselves, for example, on line number 4 of the TypeScript file. Okay, we position ourselves here before reaching this line. Let's reload this page. Notice that we are conducting a debug directly on the app.ts or TypeScript file. We have information here relating to the file we are debugging. For example, here we can see the value of x when we placed this breakpoint, meaning before assigning it the value 10, we are reading that the value of this variable is 3. We can carry out a more complex debug with the original TypeScript files. Basically, this option serves us for this, which I'm going to comment, since we uncommented it solely for demonstration purposes. I will also delete these files with a .map extension, as we don't need them at the moment. The following options we'll explore in the config file are the ones named outDir and rootDir. We also have this option called outFile, but we will skip it for now. So let's analyze these options called outDir and rootDir. Up to this point, we have created a number of files within the same root folder as part of our project. If we were to examine how the folder currently looks, we would see that all of the files are within the same folder named Hello World. Well, in more complex projects, this does not happen, but there is a stricter organization of the files instead. On one hand, we have a folder that stores the source files, which in this case would be the TypeScript files, and we would also have another folder where we would host the JavaScript files. In typical web projects, there's a folder commonly known as source, used to store all the uncompiled or original files. So we will proceed to place these files inside the source folder. Typically, we would also, well, here we will insert the files. Okay, they are there now. We could also have a second folder as part of the main directory called dist. Okay, so we now have these two folders. Next, we're going back to the configuration file. We will close these two files. They aren't serving us at the moment. We will examine the first option named outDir. Basically, if we look at the description of this feature, it tells us that we can redirect the structure of the output to a specific directory we specify. I will proceed to carry out the compilation of this project so you can see what is generated with this current structure. I execute the command. The compilation takes place and you can see the files are generated within the same folder called src, where we have hosted TypeScript files. What we want is to host these JavaScript files inside the folder called dist. How can we do this? Well, we can do this easily thanks to this option called outDir. Here we're going to specify that we want to place the compiled files inside a folder called dist. I'm going to save the changes to this file. I'm going to proceed once again to carry out the compilation of the project. Watch what's going to happen. The compilation takes place and the JavaScript files are placed directly in a folder called dist. Then they have been generated in this folder and we already have more order. Even if you didn't have this folder created, see what happens if I run the compilation one more time. The creation of this folder and the files that we see here is carried out. So this is a big step already to manage a better order as part of our project. Let's analyze the second option, which is called rootDir. Basically, this option tells us that it allows us to specify the root directory of the input files. This may sound a bit confusing and may even confuse some developers starting out with TypeScript. Perhaps this would make us think that we could have multiple folders of TypeScript files and that we could specify which files we want to compile from which folder. However, this is not the case. Basically, this option allows us to choose whether we want to carry out the complete compilation of the project structure tree or not. Let's see it in a practical way so that this concept is perfectly understood. I'm going to create a folder inside the source folder called, for example, sub to give it a name. Inside this subfolder, which is located in the src folder, I'm going to create a new file called, for example, test.ts. I'm going to write some very simple code, for example, a console.log that says test. With this change we've made, let's look at the structure we currently have. Notice what's going to happen if I commence the project compilation. Okay, the files have been generated. Notice what happens next. We have the dist folder here, a subfolder, and we have the JavaScript files. But what would happen if, as part of the output we have as part of the project, we needed the structure from a folder named src, just as we have here? That is, as part of the root of this directory, we had this src folder. If you notice, we currently only have the output from the subfolder and the corresponding files at this level. This happens because the inferred value for rootDir, which we have here, which is the default behavior, is to obtain the longest common path of all non-declaration input files, which in this case is the src folder. Let's carry out a rootDir change and remove this slash, so rootDir is left with a dot. I'm going to delete the dist folder for a clearer view. Save the changes to this file and compile this project once more to show you the result. Okay, we have the dist folder here. Notice what has happened. We have the dist folder here, but we have this subfolder called src, which is actually hosting this subfolder and the JavaScript files. That is, the src folder is now included as part of the distribution directory structure. We can see this better in the Explorer. Take a look at what has happened. We have the project, we have the dist folder, and we have this folder named src, which has all the corresponding files we saw earlier. So this is what these two properties or functionalities outDir and rootDir are for. Let's continue analyzing some options in the TypeScript configuration file. Let's skip this option that says composite. We also skip ts build info file. We have here an interesting option called removeComments, which is marked as false with its default value. Basically, here it indicates us this option that will allow us to avoid the output of the comments of the TypeScript files. Let's make this an action. I'm going to proceed to delete this folder called dist. And I'm going to proceed to modify, for example, the file app.ts. I'm going to place some comment, I save the changes of this file, and I'm going to proceed once again to compile this project. Okay, if we review the resulting file, that is the file app.json, notice that at this moment, yes, it is emitting me the comment. If I proceed to uncomment this line of the configuration file and save the changes, I will proceed once again to compile the project. And if we go to the app.js file, this comment that we have marked above does not really appear anymore. Let's see what other options we have as part of the configuration file. We have this section or this line that says noEmit, which basically allows me not to emit any kind of output. That is, it allows us to disable the generation of JavaScript files. This can sound a little strange, but it can be useful, for example, if we only need to carry out the revision of some type of problem that we have as far as the structure of the code and not so much in the part of operation. If we want to see some very simple thing or we want to carry out some very simple modification, we can enable this option, and with this, we will avoid the generation of the whole set of JavaScript files. We also have this option that says import helpers, downlevelIteration, that basically have to do with an option. I show it to you so that you can see it better. With the option to carry out the generation of code for previous versions or in an earlier version of JavaScript. Basically, here we can see some examples. We can see how a code section with a TypeScript loop would be written. We could see here if we did not use the option called downlevelIteration. We would have here the result that uses some new features of the new JavaScript versions. If we enable the downlevelIteration option, notice that the generated code is the one we see here. We have more extensive code, but it would allow us to carry out some more detailed debugging. However, we have the downside that it generates much more code. This code can be very large in case we have wider loops. So basically, this is what this option is for. These downlevelIteration options and this one for imports helpers. We are also going to leave the isolate modules option for later. It is important to note that as part of the configuration file, there are options that won't appear as part of this file. However, we have them available for use if needed. This is the case, for instance, for an option called noEmitOnError, which is a very interesting option. Basically, this option allows us to stop the compilation and generation of JavaScript files as soon as an error is found in any of the TypeScript files. This can be useful for those who might want to have 100% valid TypeScript code before uploading it to a code repository, for example. Let's do an example of this. I will proceed to delete the JavaScript files. Let's proceed to analyze the next part of our configuration file, which has to do with the strict type checking options. To carry out these examples, I'm going to solve the problem that I have in my TypeScript file so that it does not cause us any type of conflict. I save the changes. I will proceed to comment also these lines that we had previously uncommented. Okay, so we have this section called strict true. Basically, this section allows us to perform some type validations in a stricter way. Beforehand, we have this section or this option enabled as true for all the different configurations that we have in the lower part. Let's analyze just some of these features. We have, for example, the first option that says no implicit any. Here it tells us some brief description about this feature. Here it indicates that, for example, we're going to throw an error in expressions and declarations with the default type as any. What does this refer to? Well, basically, we have already seen this before, that if a type, as for example, a parameter of a function, is declared as a type any, since it does not have a data type assigned, then in case this is activated or this option is activated, it is going to throw an error message to us. Let's see it in a more practical way. I'm going to remove this code that I wrote earlier. I'm going to quickly create a function called print, which is going to have or receive a parameter, which we're going to print later. See what happens. If I have this option activated, here if we position our name, it indicates me that the parameter name has implicitly an any type. If we return to the configuration file and uncomment this option and we indicate that it is equal to false, we save the changes, notice that it will happen in the app.ts file. This error that we had previously has disappeared. So basically, this option called no implicit any is used for this. The next option is called strict null checks. The description says that it allows or enables a check against some kind of null value that we might receive as part of our application. Let's see this in a practical way. Let's go ahead and quickly declare a user array. I'm going to insert a couple of objects like this. I'm going to indicate that I want the first object to have a property called name that's equal to, for example, Hector. I'll put a comma to create a second object, and within it, I'll insert a second object that also has a property called name, and let's put, for example, Ricardo as its value. So we have a couple of objects that are part of our array. Now, since I have this pair of elements that are part of my array, I'm going to declare a constant named, for example, logged, and I'll try to search for an element in my array through users. Here we're going to use the find method. This feature only works when we have enabled the target option ES6. If we have ES5, this will fail. So remember to set ES6 as the target. We have the find method and we will indicate that we want to find an element through a lambda expression. We write x.name equals, let's search for example, the name Jose. Obviously, as you can see, this name Jose doesn't exist, or this string Jose doesn't exist as part of the elements in my array. So here this element does not exist and therefore we could have a null value. If we try to do a console.log, specifically of logged.name, notice what happens. I will remove this question mark that was automatically placed for me and look what happens. It tells me that the object could possibly be declared as undefined, meaning we could receive a null value if we don't find the value we have here. For that, we use this strict null checks option to validate these types of data. If we comment out this option and set its value to false, save the changes, notice the previously existing problem disappears. It's because we are disabling this type of error check. There are other options here such as strict function types, which allows or enables checks for function types. We will not be looking at this option in this video. We also have the option called strict bind call apply, which tells us it enables stricter checks for bind, call, and apply methods in functions. We will quickly look at this feature. We return to the app.ts file, and basically with this option in the config file, when this option is set, TypeScript will check that the built-in functions call, bind, and apply methods are invoked with the correct argument for the underlying function. What does this mean? Well, we'll swiftly perform an additional test to validate this. We will create, or let's assume we're creating a function. Let's call it fn, and it takes a parameter x of type string. As part of this method, we return a method called parseInt, which is a method that exists as part of the functions we have available in TypeScript. We pass the value x, and we have a valid function here. Let's now suppose that we have a constant n1 equal to a, and we will invoke the function through the call method. We will pass as the first argument, which says that it is this arg. We will set it as undefined, and as the second parameter, which is the first parameter of our function, we will pass a string, for example, test. We put the semicolon, and we see that we have no problem with this method. However, if we try to create a second constant and call the code method again, we pass an undefined, and we pass a type of data that does not correspond to the definition of our function that is expecting a string. Notice that it is indicating that a boolean type argument is not assignable to a string type parameter. So with this, we are validating these types of issues that we see here with this option or this configuration of strict bind call apply. If we disable this option or set it as false, see what happens. Okay, this error has disappeared, and with this, we are no longer validating that these types of methods are invoked with the correct argument for the functions we are invoking. So these are ways that we can persuade the TypeScript compiler not to show us these types of errors. This may be useful to you on some occasion for certain purposes. We have some additional options such as strict property initialization, which has to do with initialization in classes. We haven't touched the topic of classes, so we won't see this option. Now implicit this. It says it throws an error in expressions this, with any type that has an implicit form. Also, this option which says always strict states that it basically allows us to emit this use strict phrase for every file. As we find in a, well, we have a true value, so observe what happens with the generated files. I'm going to quickly compile the project. Okay, we have here a JavaScript file, and notice at the beginning of this file, we have this section that says use strict. So if we disable this option of always strict, essentially this used strict code section wouldn't be generated in each of the files. This is basically one of the uses for matters that allow us to establish or behave a little stricter with the declarations we make or with the source code we have in our TypeScript files. We're going to leave this option as strict true. Once we have analyzed this part or that section that has to do with the strict checking of different points of our program, we will review this section on additional checks. We have several options here that are quite interesting. For example, the first option allows us to report errors in different unused local variables. We have the second option that allows us to do something similar, but this time for parameters. We have this third option that allows us to validate or report errors when a function does not return a value and it declares that it will return a value. We have a fourth option that allows us to validate when there are cases in a function that return a value, or rather, when we have a statement in which a value is returned, but not all points in that function return a value. Let's see this in a more practical way. Let's start by analyzing this section, or this option that says no unused locals. Let's quickly go back to the app.ts file. Now let's position ourselves within one of the functions that we have previously created. For example, this function called print. Basically, here I'm going to declare a function. For instance, let's call it x it's of numerical type and it's equal to 10. We have declared this variable. Let's save the file. Notice that at this moment, the variable does not cause any problems. I'm going to go to the configuration file, I'll uncomment this line, and I'll save this file to indicate that we want to report when we have unused variables. Okay, we return to the app.ts file, and here it is already marking this error on variable x because it is indicating that the variable x is being declared but its value has never been read or we are not using it. We can also return to the file and we can carry out. Let's uncomment this line that says no unused parameters. I save the changes and here, for example, in the function I'm going to use a second variable. For example, a variable called t or a parameter called t, and here it is immediately marking an error indicating that t is being declared but its value is not being used. And indeed, we also have this error where it is being implicitly declared as any. We also have this option that allows us to validate when information isn't returned on all function paths. What does this mean? Well, basically, we're going to uncomment this line and return to our print function. Here, for instance, let's suppose we make an if statement to compare if x, for example, is less than 10. And we return something, say a string called test. In this case, note that by default, we don't have any error because I've marked this option as false. If I mark it as true and save the changes, we return to the function. Note that a warning shows up here indicating that not all the paths of this function are returning a value. So that's what this option is useful for. We also have these no fall through cases in switch option where we can validate things similar to what we did with the above option, but with a switch statement. We also have this no unchecked indexed access option for including the word undefined or the undefined data type in index results. We won't cover these options, but the three we've looked at are quite interesting to work with. We will comment out these files to avoid any issues with the TypeScript file. We have a couple of additional options that we can use in our configuration file that will allow us to work with the files specifically. These options will allow us to carry out the inclusion or exclusion of certain files that we want to compile or do not want to compile as part of our project. We will set these options after this curly brace, after compiler options. Let's put a comma here. And we have the option called include, to include a set of files that we want to work on or want to compile. Within this include, we will place the different files that we want to include only as part of the compilation. For instance, suppose that we only want to compile the file app.ts. So I will specify here that I want to include this file, which is located in the root of the directory /app.ts. Okay, I'm going to save these changes and then compile my project. Notice that the JavaScript file for this TypeScript file has indeed been generated only. The file for hello world or test hasn't been generated. Okay, so with this we can include different files. We write quotes period source / hello world.ts. Save the changes and then carry out a new compilation. Notice that on this occasion, the JavaScript files has been generated successfully. I'm going to delete these files again, and now I'm going to show you the option called Excludes. Basically, this option will allow us to exclude various files from the project's compilation. For example, suppose we want to exclude the file app.ts as part of the project's compilation. Then we write the word exclude. I'm going to carry out the compilation once more for this project. Notice that the JavaScript files have been generated for both the helloworld.ts and the test.ts files. However, for the file named app.ts, the JavaScript file hasn't been generated since we've excluded it from the list of files we want TypeScript to compile or not compile. We have reached one of the critical moments of our course. This is because we will learn how to set up a server for apps based on TypeScript. Previously, we had created an index.html file, and to practically view it, we had to open the File Explorer and directly open this file. However, notice that the path it shows us at the top is the full path referring to the name of the system, followed by the folders, and finally the name of the index.html file. Ideally, we would have a web server to facilitate the visualization of the information that we are developing in our TypeScript project. It's also a way for us to debug these TypeScript-based applications. Let's proceed to configure the project to quickly set up a server, eliminating the need to open this file from our File Explorer. To carry out this task, we will use an extension called Live Server. Let us move on to our extension section and search for Live Server. Okay, we have this tool here from ReadWeekday. Let's proceed to install this tool. After a few seconds, this tool has been successfully installed. I will close this tab. Notice that an option that says Go Live has appeared at the bottom of our Visual Studio Code. I will press this button, and it basically tells me that this server has started on this port. I'm going to allow access through the firewall to avoid any kind of problem. With this, we have our web server up and running. If we press this button again, we will go offline. If we press the button again, we restart the server, and we can open a browser to start tests. Let's open the Chrome browser. Notice that we have the URL here, but we no longer have the URL we had before, which was the full extension, the full file path, but now we have a server at localhost. So with this, we can make dynamic changes from Visual Studio Code. Let's test this. We'll go to the index.html file and proceed to insert an h1 tag. Let's put testing TypeScript inside this tag, for example. Let's save the changes. Notice that automatically these changes are reflected directly in the HTML file. If we make any changes, for example, add 3 dots to this text, save the changes, we are automatically previewing the changes directly in the browser. This is one of the things I like about this tool I've previously shown you that allows us to visualize the changes in real time of the changes we're making to the HTML files. Okay, and what will happen with the TypeScript files? Will we be able to see the changes immediately as well? Well, to see this, I'm going to go back to one of the Visual Studio Code files. I'm specifically going to open the file called app.ts. We already have several functions here that we created earlier. I'm going to proceed to comment out this code. What I'm going to do next is create a quick function called getMessage. It will not receive any type of argument, but it will indicate that we want to return a string. We're going to make a return, for example, hello world. Okay, we have our TypeScript file. Let's go back to the index.html file. We will remove the h1 tag that we added earlier, and we'll add a div element with an ID, for example, displayDiv. We close this tag. Next, we're going to write a script tag. Within this script tag, we're going to use document.getElementById to get that tag's name, or the tag itself. So we're going to get the element named displayDiv.innerHTML, and this will be equal to getMessage. That is essentially the function we have defined in the TypeScript file. The idea is that when we generate this JavaScript function from the TypeScript file, this file will be read from the HTML file, and we can get the content of this displayDiv tag from this function. We are going to have to compile this project. so that we can see the changes in real time and don't have to keep compiling the project over and over. We'll compile the project but with the watch or W flag to monitor changes in TypeScript files. I'm going to start compiling in watch mode. I'm going to review quickly. I'm going to remove this line from Exclude in my configuration file, as this will prevent the file from being generated. I save the changes, and here we have the app.js file. Okay, so now that we have this app.js file ready, I'm going to return to the index.html file and check the configuration folder. I have the JavaScript file actually in the src folder, so I need to indicate that here. src/app.js or the JavaScript file. Okay, with what we've done, we now have the JavaScript file with this getMessage function. We have the index.html file. Let's check what we have here. Well, indeed, we have in the browser the message hello world, which refers to what we have done, having to do with the setup or with this piece of code that returns a message, which in this case is the string hello world. I'm going to make a change in this string. For example, I will add some additional exclamation marks at the end of the string. I save the changes. Notice that since we have the watch mode activated, the compilation of the files from TypeScript to JavaScript takes place. This causes this tool or this web server that we have raised, or the tool that allows us to preview the changes, to notice the change that happens in the JavaScript file, and that's why we have here the deployment of this hello world string without any problem. So this is quite useful when we develop web applications, because we will be able to see the changes that we make in the HTML files, CSS files, and JavaScript files in real time and instantaneously, without having to compile the project over and over again, or having to refresh the web page. So this tool is quite useful. I recommend you install it because we will use it throughout the course. We're going to carry out another one of the indispensable configurations for developing web applications based on TypeScript, and even in any other programming language. This is about how to carry out the configuration or how we can debug an application based on TypeScript. Well, what we're going to do to execute this task is first place a breakpoint where we want the application to pass so we can carry out some kind of examination or examine the source code of our files or our TypeScript files. We've previously seen that if we load an application based on TypeScript, here in More Tools, Development Tools, basically in the debugger we had the source code of the JavaScript file, and we could set breakpoints here to carry out debugging in the browser. But what would happen if we wanted to utilize the benefits and advantages of Visual Studio Code to perform these tasks? Well, we can also do that. We're going to declare a variable, for example, x equals 10, and then x equals 25. This is just to place a breakpoint in Visual Studio Code. I'm going to place it on line 37. Here, logically, if I refresh this website, we don't reach the breakpoint, because we're really not starting a debugging as part of this project. How can we start a debugging? Basically, what we're going to do is save the changes in the file, and I'm going to click on this button that says Run. From here, we can click on this blue button that says Run and Debug. Here we can select different environments. I can select the Edge::launch environment. I will select this option as I want to launch this application in the Edge browser. So I select the option. In case you see that nothing happens, that everything stays the same, press the button again and click on it once more. Now we've created a configuration file as part of our project. This folder named VS Code was created with a file called launch.js, which is essentially a configuration file that allows us to debug our application in the browser. Here, it's important to configure the URL we see here. Right now, we have localhost 8080, but we want to debug port 5500. 127.0.0.1 also refers to localhost. Therefore, it's the same whether you put localhost or this address, as you see here. All I'm going to do is copy the port, and I'm going to replace it here with 5500. I leave webroot as it is. Webroot is the root folder of my project, or everything I have here as part of my project. This folder that contains all the files. I leave the type request and name as is. This configuration will work if you have Chrome installed. In case you have another browser installed, you can configure different options, like this one found in Visual Studio Code's documentation. I'm going to leave the previous configuration and quickly install Chrome. Once I've installed the Chrome browser, I'm going to use this button to debug my application. I can do this by clicking this green button here, or by clicking on the options at the top and selecting Start Debugging. I'm going to click on the green button appearing here. Notice that this launches a new window where we'll be able to preview the application. Automatically, it inserts localhost followed by 5500, which is the URL I specified in the configuration file. Let's do some tests to see if this works properly. First of all, let's see if the automatic code generation still functions. In this instance, I'm going to remove these exclamation points. I save the changes and notice that the file or project's watch mode is still automatically activated. We also plan to test by placing a breakpoint on this line, as we previously indicated. However, notice that we have a breakpoint here, and it says we have a breakpoint that appears to be disconnected from the project. For this, you must have the project or execution, and we need to go to the tsconfig.json configuration file to enable one of the options that we already saw previously, which is the option called source map, which I have here. I'm going to uncomment this line. You need to do this to correctly use what we explained earlier, or to initiate the debugging process. Once we have done this, we will proceed to start the application once more. Note that on this occasion it started the application and immediately we have the breakpoint, or we reached the breakpoint that is on line 37 without doing anything else. So here we are ready to perform a debug, like seeing the value we have in X before running this line. We have some options such as adding different watches or observing different elements of the source code. We have the call stack, we have breakpoints, load the script, etc. We have all the features of Visual Studio Code, which we can use to speed up our developments. This is how we can carry out a step-by-step debugging, or alternatively, click on continue to execute the code. Thus, we have now covered the part about seeing real-time changes in what we do in the project, and likewise, how to carry out debugging in a TypeScript-based project, which will be of enormous help in the following videos and in the projects we will carry out next. We have already seen the types of data that we can use in TypeScript. We have also already seen some compilation options as part of our TypeScript projects. In this specific module, I want to focus on something more practical, something to get us out of that routine of the theoretical part and focus more on carrying out a project that is a real, simple project, but that will allow us to practice what we have seen up to this point. The project in question is called Color Switcher, and basically it will allow us to get a random color and apply this color to the background of our web page that we are developing with TypeScript. Okay, then let's start with this project. What I'm going to start doing is creating a new folder. My project folder or cars folder is here. It's called TypeScript Cars. I'm going to proceed to create a new folder named Color Switcher. Okay, you can name it whatever you want. I'm going to rename it, for example, to number 2, or put a 2 at the beginning, so that we have a more appropriate order. Now that we have this ready, I'm going to proceed to open this folder in Visual Studio Code. Okay, so I run Visual Studio Code. Next, I'm going to click on this button that says Open Folder. Okay, I paste the folder and click on Select Folder to open this folder. Okay, now that we have this folder ready, let's proceed to create first a new file by clicking on this icon. This file will be called, for example, index.html. It will be our base file or the main file, where we will see all the changes. We are also going to proceed to copy a file, which you will find as part of the resources of this section or for this class as such. The file is called or is found in the assets folder, and it's called styles. It's basically a file that already has some predefined styles, so that you don't have to mess around creating this style file, since we're going to focus, or the purpose is to focus on the functionalities of TypeScript. Then we're going to proceed to open the content. We can open it with code. We'll copy this content, and I'm going to proceed to create a new file called styles.css. You could also have copied the file into the folder, but we're going to paste here this file on this occasion. Notice that we have here different styles that we will be able to use throughout our application. So with this, we no longer have to worry about designing the graphical interface of the project, and we can do it much faster. I'm saving the changes to this file. I'm going to close it, and then I'm going to proceed to add a file called app.ts, which will be the TypeScript file. I'm going to leave it on this occasion at the root of the project, since it's a very simple project. Later we're going to see how to create a more complex file, well, a more complex project, and carry out the organization of the different files in different, more specific folders. Now that we have this ready, we are going to return to the index.html file, and this is because we want to create a template, or we want to use the HTML:5 template. We're going to press the enter key, and with this HTML code is created in a very simple way. What we are going to do is place a link rel equal to style sheet with an href to the file styles.css. Okay, now that we have this ready as part of the body, we are also going to proceed to add the script tag. We will indicate that the source of this script will be found in app.js. We still have not created the JavaScript file, as we're yet to compile the TypeScript file. Don't worry about that at this moment. We will begin by designing our web page to define different elements as part of the DOM document. As part of the body, we'll declare a nav element. Okay, we define it here. Inside this nav element will essentially serve us in defining our web page navigation. It is merely a cosmetic detail. It doesn't have much influence or importance in our application. It is simply to establish a good looking style. Inside, we can declare a set of classes. In the case of Visual Studio Code, if you want to create a class quickly, you can do it by writing div, then going back and writing class equals and the name of your class. But there is an easier way to do this. By placing a dot, we see that it is an Emmet abbreviation. With this, we can carry out the declaration of a class. We put the name, for example, map, center, and press the enter key or tab key, and see that this div is created immediately, so we can create div elements very simply. Up next, we will declare an h4 element, and we will name it color switcher. Since we have this ready, we will proceed to declare an unordered list element. We can create this quickly by typing ul and pressing the tab or enter key. We will give it a class name that is already predefined in the style file. So we will call it navlinks. Okay. Within this unordered list, we'll insert a first element that refers with an href to the index.html page. Okay, let's give a title to this navigation menu, which for example says home, or could have some other name. If you want to put other elements as part of the navigation menu, you could easily do so by copying one of these elements. We're going to carry out the test of how this graphically looks in the browser. I have saved the changes, and to visualize these changes, notice that at the bottom we already see the extension that we saw in a previous lesson, which allowed us to see in real time the changes. If you want to activate this tool, we can right-click on one of the HTML files, right-click, and we have the option to open this page with Live Server. We click then on this option, we indicate that we wish to open this application in the browser, and we will give it a few seconds. Okay, here we have our application, and notice that we already have this pretty menu, which basically refers us that we can navigate to index.html easily. Here you can add more elements, as I told you before, if you wanted to add some other type of tools as part of our application. I'm going to put this window next to Visual Studio Code to be able to preview the changes easily. I'm going to make the browser window a bit smaller, and we are going to proceed defining our graphical interface. Once we define the nav element and its different elements, we will proceed to define a main type element, and inside we will define a class called container. You have to get used to this syntax that I'm showing you so you can speed up your developments if you have never worked this way before. So we create this div element, which is called that has the class container, and inside we're going to add an h2 element that says, for example, background color, and we will place a span type element. This is because we want to carry out the modification of the text that appears as part of this h2 element. We are going to assign to this span part a class that we will call color. Okay, within the span element, as we see here, we are going to set a color that already exists by default, which is the current background color, which in this case is F1, F5, F8. Okay, once this is done, let's save the changes. We preview in the browser and see that we already have this nice section that shows us the background color, and here in a different color this hexadecimal color that we have here. Once our h2 tag is ready, we're going to proceed to add a button. We are going to assign it a class called btn, also a class called btnHero, and we're going to give it an ID to be able to use this button later. Let's call it, for example, btn as an ID. Okay, let's call it as a title or as text. For example, we're going to put something like generate. Okay, we save the changes and we already have our button ready that will allow us to carry out the generation of the different colors. Okay, we are ready with the HTML file. I am going to proceed to close this file and go directly to the TypeScript file. So, as part of this file, the first thing we're going to do is define an array of strings that will actually be a group of different characters that will allow us to carry out the representation of a hexadecimal value that forms part of the color or the color that we're going to assign as part of the background of our screen or our page as we have here. Then, to define this set of values, we're going to create a constant that we will call xValues, and using the knowledge we have, we're going to indicate that we want these values to be only strings. As we want it to be an array, we're going to assign this string with brackets, and we will proceed to start defining each of the values. We're going to define then the number 0, number 1, number 2, number 3, number 4, number 5, number 6, I define the number 7 in the next line. I'm going to put a comma after this number 6, then number 7, comma, number 8, comma, and finally number 9. But as a hexadecimal value can also have letters from A to F, we're also going to include within the array the values A, B, C, D, E, and F. With this, we have our array ready, which we're going to use to get or construct our hexadecimal value. Now that we have it ready, the next step we're going to take is to obtain our button in order to handle the click event, and we're also going to proceed to get our color element or our color class to change the background color of our web page. What we're going to do next is declare a constant, for example btn, which will be equal to document.getElementById, as I know the ID of the element, which is btn. This is the element we have in our index.html file. This element here with ID equals btn. The next step we aim to achieve is to get this span element we see here that has this color class. So we're going to revert back to our TypeScript file, and I'm going to proceed to define a new constant named color, which will be equal to document. Here we're going to execute a method called querySelector that we have here thanks to Visual Studio Code. Okay, we're going to specify that we want to obtain the elements whose class is the same as color. Okay, now that we have this set up, we're going to declare an event listener for our button. So we indicate btn at event listener. We indicate that we want to handle the click event. I'm also going to indicate that I want to use or declare a function for the handling of this click event. I position myself within the handler or this listener, and I'm going to do a console.log document.body to test that everything works correctly. We're going to save the changes, but we see that really nothing has happened as part of our website. This is because, as you probably have remembered, we need to initialize the automatic compilation or the watch part to immediately visualize the changes. To do this, we're going to open the terminal. We're going to open a new terminal. To use this action globally in our project, remember that we first have to create a configuration file. We do this with the command tsc space and a hyphen followed by the word init. Press the enter key, and this has created the tsconfig.json file. Now we can execute the command tsc space -w to start the compilation in watch mode. Here we see that immediately a problem arises and it indicates to us that the object is possible null. So TypeScript begins to carry out the compilation and visualizes that there may be problems and we have to correct these problems. In the case of this button, of this line that we have here, which is causing the problem, we're going to add an exclamation mark at the end. This carries out the correction of what we previously had. It's not really a correction, but with this, we are indicating to the TypeScript compiler that we are sure there is an element called btn and that we will find it. So this stops causing this problem, this section of code. Let's save the changes. We see we no longer have errors, and to see if this is working correctly, we're going to go to More Tools, Developer Tools. Let's go to the console. We're going to proceed to click on this Generate Color button. So we click on the button and this shows us the body of the document as we have it here. We see that this is working correctly. Okay, what's the next step? The next step is that we want to change the background color that we have here and the content of the text that appears here to change this text for the hexadecimal code that we generate randomly. How can we do this? Well, let's go back to our event listener that we have here and let's modify this code a bit. First off, let's declare a variable called xColor that equals to, and we put a hashtag symbol as part of this string as such. We can here specify that we want this variable to be a string only through this colon, and the string keyword to declare, remember, the type of data string associated with this variable. Then we're going to make a for loop, and execute the cycle 6 times. Now you'll see why. So let's declare this for loop, and here we're going to declare xColor plus equals x values, and we're going to put a bracket and a 0 value. What are we doing here? Well, essentially, we want to assemble a string that has a similar structure to this. For example, let's put 1, 2, 3, 4, 5, 6. This is a string or in hex format that will allow us to assign the background color of this web page. This in case you have not previously worked with these hexadecimal values. So with this loop, we're going to cycle 6 times and we will concatenate a value to the xColor string. What is this value? Essentially, what we are doing here is going to the array called xValues, and in this particular case, we are only reading the value that is located at index 0, that is, this value that is found here. We are going to do this only at this moment for demonstration purposes. Later we will correct what we are doing. Once we have this string in hex format, we will proceed to modify color.textContent, and this will be equal to xColor. I will remove this question mark that was shown to me earlier, and note that it is indicating a new issue to me, suggesting that this object may be null. This is because we have the same previous issue where this query selector can't result in null values if it doesn't find an element with such class. So I will then put an exclamation point at the end. And with that, the problem is solved. I'm going to save the changes. I go to the web page, click on Generate Color, and note that it satisfactorily places this string with a string containing only 0 values. This is due to what I explained earlier. We will also change the background color via document.body.style.backgroundColor. We have this property here. Let's indicate that we want it to be equal to xColor. We save the changes. Let's click on the button again and notice that the page background has changed to black. So the next step is to convert these values into random values so that we don't have this specific assignment as such. How can we do this? Well, let's quickly create a function called getRandomNumber. Okay, since that's ready, we simply indicate that we want to return a math.random to generate a random value. With what we have done, we can now change the 0 to getRandomNumber. Or well, that would seem so. Let's save the changes. I click on Generate Color. Notice that we have a value here, a hash symbol undefined. Why is this happening? Well, we can quickly check it if we do a console.log of getRandomNumber to give us an idea of what's happening. Let's save the changes. We click on Generate Color. Let's go to the console. Notice what's really happening. What's really happening is that a series of numbers are being generated, but these numbers don't really correspond to the values I have as part of my array. Remember, what we want is to get a value that is part of this array called xValues, and it has to be an integer for this to work properly. The next thing we have to do then to solve this problem and obtain a value that refers to the number of elements that we see here is to multiply this value by the number of elements we have as part of our array. We can do this by multiplying math.random by xValues.length, which is the number of elements in our array. Let's save the changes, click on Generate Color, and you'll see that we now have a whole number followed by a decimal number. We can choose any of these values. The next step is to remove or eliminate this hexadecimal section that is part of each number. We can do this thanks to a function called floor. So let's do this. We'll apply this function via math.floor, and within these brackets we'll include all of this. Having done this, let's save the changes again. Click on Generate Color, and you'll see that we now successfully have different numeric values that correspond to the elements in our array. We are successfully generating a background color and its respective hexadecimal value. If we press this button multiple times, see how we can quickly change the colors generated on our background. So with this, we have completed this lab or practical lesson, which I find very interesting. In the next lesson, we'll see how we can apply a little more of what we saw by creating a callback to implement the same behavior but in a different way, for demonstration purposes or just for fun. Okay, let's keep practicing a bit of what we have seen so far then. To do this, let's redefine our code that we wrote in the previous lesson. This, as I told you before, is only for demonstrative purposes and for fun. You don't have to do it, but if you want to practice a little bit more, it's recommended to do it. Then what I'm going to proceed to do is to copy this section of this event handler. I'm going to comment by pressing Ctrl key and C keys. And with that, this section of code is commented. I paste this section of code and I will proceed to declare a new function as part of my code. Basically, what I'm going to do is add a function that will allow me to pass a callback as part of the definition of the parameters of this function, which will carry out the color generation, and once it has carried out the color generation, carry out the update of the graphical interface. So to do this, I'm going to create a function called generateColor. As I told you before, we're going to pass here a callback or a callback function. Remember that we can define it directly from here. I'm going to proceed then to define this callback. I indicate that it is going to be called update, and it is going to contain an input parameter called color of a data type string, and I indicate that it is not going to return anything. Within this function, I'm going to proceed to cut this section of code, this let or this variable definition up to the for loop. I cut the code and paste it as part of my method or my generateColor function. Once I have this ready, I'm going to invoke the function called update, passing the result of the color generation that is in the variable xColor. Once I have this ready, I'm going to make the window bigger. I'm going to proceed back here to my event handler. Inside, I'm going to indicate that I want to invoke, once I click the button, I want to invoke the method that's called generateColor. Here I can define what is the functionality that I am going to execute once it has finished processing the generation of the color. I'm going to indicate that I want to pass a parameter. I can put it as I want, for example x, which is going to be the result of the generation of this color. Through a lambda expression, I'm going to create a function, and here I'm going to indicate that I want to modify, or well, I can cut and paste this content. I cut and paste, and basically here I'm doing the same thing that I was doing before. I'm just going to change this xColor to the x parameter, and also this xColor to the x parameter. This should have a behavior, so pretty much the same behavior. Basically, here notice that what I have done is simply to declare a function. It receives a callback. When it finishes the processing, I invoke the callback, passing the result. It is for that reason that we can here assign these values. Let's see if this works correctly. I save the changes, go back to the browser, click on generateColor, and notice that we have the same behavior. In case there are still some doubts about the use of the callbacks, this piece of code that I have here, I'm going to proceed to copy this event listener. I copy, I comment this functionality, and I'm going to explain it to you in a different way. This that I have here is the equivalent of me having a declared function called, for example, updateUI, receiving a parameter, for example, called xColor, of a string data type, and inside this function I have this content that I have here. Then I cut this content, paste it, and I'm going to change the name of the parameter to xColor. So as I told you, this is what I have here is the equivalent of me not directly having the creation here of my function, but here I would have the invocation of generateColor and pass the name of the method, which in this case is updateUI. And basically the processing would be as follows. I invoke the generateColor method that receives a callback. A callback is a function that we can invoke once the processing is finished, as we have seen before. So the processing is done. We invoke the callback, which is actually the invocation of the method, which is called updateUI. That's why we have the same functionality. If I proceed to save the changes, go back to my browser window, click on generateColor, and notice that we have exactly the same behavior as we had before. Then, with this we already have a random color generator that is quite functional, quite pretty, and that has served us to practice what we have seen up to these moments.